We are going to. Yeah, so let's do the usual thing and have a quick round of introductions. I'm going to pass around the basket. If you feel like dropping your business card in, we'll then share that information with all the attendees. And welcome to our semi-annual advisory board meeting. A quick introduction. I'm Joe Rizzoni, a professor in the Department of Mechanical and Aerospace Engineering, and I also have been the director of the Center for Automotive Research for a few years. And what I'd like to do is just pass the microphone around and name and company and we'll keep it.
Hi, Thomas Sheldon with Honda. Chief Village, a Ford Motor Company.
Good morning, everybody. Most of it. General Motors.
And Stable Data.
Golden, Ford Warner.
Lori Herman, independent consultant. Don Ryan, for Energy Innovators.
Kyle Shen, McSaris.
Jay Dice, 4C Power.
You know, I love this, but I don't have to say. I'm Jim Jordan and I'm retired.
That member, I'm the associate dean for research and development here at OSU.
Brian Zim, Ohio State Technology Commercialization.
Kelly Sitz, Corporate and Foundation Engagement at Ohio State.
Ed Smith, executive embedded software consulting. David Emerling, Car. Mike Diverso, senior director of corporate foundational engagement. Robert Lane, active on energy.
Dave Tomasco, Associate Dean of Academic Programs in the College of Engineering.
Hi, Mary Andrews, the Argo Mission Alert.
Derek Schmidt, Honda. Derek Davis from Honda.
Shiva Muthuswamy from Pavani Equipment Corporation.
Greg Janford from the Center for Automotive Research.
Stephanie Stockard, Ohio State.
Ed Dahlstrom, Stack Energy.
Who's got to do that? You got it. Ken Helster, Mobility Venture Solutions.
Josh Peel, Oak Ridge National Laboratory.
Who's open about there yet?
Derek Beer, Ford Racing.
Yeah, Chris Davis, Car.
Jeannie Willis, City of Dublin.
Mark Schwabro, retired.
Jeff Hefner with Schaffner.
I'm Chris Ball. I'm with the Electroscience Laboratory here at Ohio State.
Brian Wozak, Stellantis.
Okay.
I'll introduce myself, Yanni Howard, Chief Engineer.
Hi, I'm Meg Dick, I'm with Car. Vicky Chattering, Drive Ohio.
Jonathan Bridges with Jobs Ohio.
Yes, yeah.
Department with IT Consulting.
Rich Granger, Drive, Ohio.
Team Fight with Honda.
AK Meyer, Drive, Ohio.
Jen Dunn, Transportation Research Center. Keith Thomasville Cummins.
Big Water Energy Safety Response Group.
And David Peck, Car.
Marcelo Canala, Canada.
Dan Lacey, Car.
So welcome all. Thank you for giving us your valuable time today. And I want to extend special thanks to Honda, who has allowed us to use their space here at 99P. We're very pleased to be here. Many of you have been to our previous meetings, and, we have increased our footprint here by a factor of about 4, probably relative to our conference group. So we're very pleased to be here, and I would like to invite Alan Sheldon from Honda to give a few words of welcome.
Thank you, Giorgio. Good morning, welcome everybody. I just wanted to go through a couple quick slides. So this space belongs to, Honda, like a global company, has a lot of various entities, and there's one called the Honda Research Institute, and that's what this space belongs to. And we work for the Honda Research Institute. So our motto there is we create knowledge that matters with an attitude that challenges for a society that flourishes. And the Honda Research Institute is a small company within Honda, about 150 people globally. And we have offices in Japan, the US, and in Germany. And in the US, we primarily have offices in San Jose and here. So here there are 2 divisions. One on the 99P Labs is one division, and another division on materials research, which I lead the one on the 99P Labs, and my colleague Chris Brooks, who I think a lot of you know, leads the one on the materials research. So why the name 99P Labs? We always get asked that, so I like to start with that. So, and within Honda, there's a lot of famous quotes from Mr. Honda. So one of them is, success represents the 1% of your work that results from the 99% that is judged a failure or called a failure. So we like to use that as an emphasis about like we try to be very agile and pivot and change quickly in our research and our projects. So we like to say we could take 99 pivots to have a successful project. So this space was founded in 2018 as a lab to work on the mission to create sustainable mobility futures through collaborative research and data-driven innovation. So we're very small, and we do a lot of our work through collaboration with university partners primarily. And of course, being here, the biggest one we collaborate with is Ohio State University. So within 99P Labs, the 4 primary areas we work in are software-defined intelligence, joint cognitive systems, sustainable energy and materials, and computational design and digital twins. If you're interested in any of those, you can talk to me. And we try to be in kind of that middle ground TRL level, kind of that Death Valley part of that Death Valley area where we're trying to take research that's maybe developed in other parts of HRI or at university and kind of push them through that mid-tier kind of TRL level for product, which is, as any of you who tried to do that before, is very hard and very challenging, but that's what we're trying to do here primarily. And like I said, we work with a lot of university partners, primarily Ohio State. And if you're interested in learning a little bit more about 99P Labs, we have a nice website and we do a lot on LinkedIn. You can follow us on LinkedIn. And that's it. With that, I'd like to just say welcome to everybody. And it's really glad that we were able to host this today as you guys are going under some facility improvements. Thank you.
Alan, thank you so much. Really grateful for your agreeing to host us today. And it is a great pleasure for me to invite the Dean of Engineering, Ann Howard, who is going to give us a little bit of an overview of where the college is. And it's really a pleasure to have you here today. Thank you for that.
Which would be. Actually, Georgia. Let's do one laptop switch.
So while they do that, one, I wanted to thank Georgia for the invitation, and also the External Advisory Board. If you think about it, this, you know, you are getting paid zero. And so the service that you provide and your belief in both CAR, engineering, as well as Ohio State, I just want to say thank you. It is truly the one thing that allows us to navigate and define what we're doing. We have that external voice that's honest. In terms of thinking about what is the future, what is the next, what is the next, what is the next. And so I just wanted to say thank you for showing up and being here and also voicing your thoughts so you can improve every year, every day. So thank you.
Sorry about this, we're trying to get that.
Bring on. Computer view seemed to lock down. What's a new one?
I don't know, I've never seen this.
I shouldn't have.
Yeah.
All right, so welcome. I'll just start talking because I actually have a lot in my head. So really what I want to do is give you an overview of the things that we're thinking about at the college, both the things that keep us up at night, but also the positives. So one, there is a lot going on with respect to the federal landscape as well as the state landscape. And how does that impact our faculty? So one, just a little bit of an overview. We did have a SB1 bill passed, which was,
Second.
So this is what I'll talk about. Some of the impacts, research enrollment, which is a positive, but also we have to think about what does that mean and other strategic initiatives. So we are navigating SB1 and how it impacts CAR, how it impacts engineering. It's really around how do the faculty, one, how do we keep them here? How do we retain them? How do we give them the autonomy? Because some of the things that we worry about, we do now have an annual review that has 3 levels. So I have to approve all reviews. The provost has to approve all reviews. And this leads to a 3-year, basically post-tenure review. What does that mean? It means that traditionally, when we think about faculty, there is this element of we teach what we teach. We have research, we do great research, we do 99 ways that are not failures, but pivots. But the environment of the university allows us to do those kinds of things. And so one of the things that links to is tenure. And so now we have a post-tenure review, which basically means that that element of not performing leads exactly or directly to either having tenure or having a finding where tenure could be revoked. And so thinking about that, how does the university then allow the freedom of exploration, the freedom of asking questions while still ensuring that we are compliant? So that's one of the biggest things. The other is syllabi. This is extra work. And when I say this is that because faculty are required to do that, there might be some angst if they talk to you around the things that they have to do that aren't necessarily aligned with them tinkering, gadgeting, doing data analysis, writing documentation. So we're trying to figure this out and work with faculty around that. And so that's really at the state level. The federal level, the biggest thing is the changes in our federal funding profile. Thinking about what does this look like? And I'll talk a little bit about that when I show you our research slide. What does this mean in terms of the areas that CAR works on? EVs, sustainability, thinking about how do you have clean energy for the future. So some of these things, the type of funding that might come may not be always aligned with the things that CAR is doing now. So we're keeping an eye out on which calls we canceled. How can we maybe pivot certain areas of research so that CAR and the researchers can still do what they're doing. And so this is impacting all universities, but we are trying to keep ahead of it so we can basically enable the faculty to do what they're doing. The other one, H-1B application fees, is now at 100K. What does that mean for our faculty? I would say we have a large number of faculty that get their PhDs here, a lot of times in the States, but they do need sponsorship. And so what is our approach? What does this look like for the young assistant professors that we want to bring in and hire? That cost is not necessarily part of our budget. So thinking of how does this impact being receptive to having a diverse set of individuals and researchers that in engineering is part of our culture, is part of our environment. And then the last, what we worry about is some of the changes in financial aid for our graduate programs. Master's students are typically, for example, self-paid. A lot of that means that they may get loans. So there's now caps on professional degrees for graduates. And so that is something we worry about. Are we now as attractive as students if they are not able to fund themselves? For PhD students, there's, especially with the application, H-1Bs, the changes, is if a student is here, there's currently a limit that they're looking at of 4 years. We know that a PhD does not take 4 years. And so what does this look like if we're bringing in students? We know that it typically takes 5 years to graduate, but they may not be allowed to stay that 5 years. And so these are the themes that we're looking at and trying to figure out because it impacts our research enterprise. So those are the negatives. For the positives, we have a number of centers and institutes. This is just a slew of them, CAR being one of them. But what it allows us in these centers and institutes are really the research arms that allow us to have faculty researchers together that are focused on very specific things. And it works very well. The college supports them with some funding, but a lot of it is they go out with grants. And what's nice about it is that it has these different disciplines. It's not just college-based engineering. It might bring in faculty from arts and science. It might be bringing in faculty from medicine, from business, from law. And it allows them to have a space to collaborate around a certain theme, a certain emphasis. And each of these centers has a director that really has a strategy of what's next, what's next, what's next. And those directors actually report to SAC, who's the Associate Dean for Research, which also then his responsibility is to line the centers and the affiliates to what we see in terms of the national landscape. Are there state initiatives that are coming where we know there will be funding that's available? How do we look at which center is most viable for going after an opportunity? How do we then support that so that we can get larger and larger grants? Again, I think the special sauce is there's one infrastructure support, but you're having faculty, not just in one department, but that are in multiple colleges, multiple departments working together, and they are free to do that. And so it's really worked great. It's really worked wonderfully. And why we know that is that this is an example of our research expenditures. You see the nice growth. And this has really been intentional. It is how do we provide the time, the space, the infrastructure for researchers to do what they're doing and remove a little bit of the barriers, as much of the barriers as we can. And we continue to remove barriers around reporting, around post awards, to really enable this. And what I put in headlines is, I just mentioned a part of the things we worry about is the federal funding landscape. So we will have, if you look at our profile, expenditures are a delay function. They're basically how much has been spent based on awarded grants. And so we have a really nice portfolio of already awarded grants. What we worry about is, well, what does this look like next year and next year when our portfolio of grants are no longer being funded? And so how does this impact our research enterprise, our research faculty, our graduate students, undergrads that work in the space if the funding is not there? How do we still continue to do great research if we're not able to support it financially? And so these are conversations around how do we define scholarship? How do we define research? How do we do more with less? And so those conversations are happening now. We have about a year to 2 years to figure this out. Because one of the things as an R1, our mission, a part of our mission is to do research, to have innovation, to impact the world, society through our innovation and our IP. And so we need to figure this out. It's not a choice. It's a non-negotiable. Understanding that we might have a half or a third less of funding to enable this research enterprise. But very great trajectory so far, which I'm actually really proud of because it's around one, creating the infrastructure, removing the barriers and letting the researchers do what they do best, which is think, innovate, develop, test, pivot over and over and over again. So enrollment, without students, we actually have no research enterprise. Without students, we have no competitions. We don't have a space at the back of car where the students are applying what they're learning in the classroom to the real world, experiential learning, which the student groups and the student competitions really, really emphasize. So here is our overall enrollment for the College of Engineering. You see that there is also an upper tick. And a lot of this is being driven by some of you in this room, companies, workforce development. How do you produce more engineers to address the needs in not just Ohio, but really the Midwest? And what are those areas of interest, of discipline that the companies are asking for? And so we have tried to rise to that challenge with respect to looking at the workforce, looking at our gaps, and really leaning into what does this mean? And so this is an increase of, and this is the hot off the press. We're now at 12,155. So every year we are doing, making a record. Now the challenge is that we don't have more faculty. We don't have more academic advisors. We don't have more space. And so how do you educate more students, give them the quality of the experience, don't water it down, but still have the access and the pathways for the students that want to attend, be engineers at Ohio State. And so we are navigating this space of what this looks like. I wanted to show you a couple of the more relevant departments. Lovely MAE. So this is mechanical aerospace engineering. You see that like huge, it's almost a hockey stick for business folks. So this is where we are now, 2,600 students in mechanical engineering, MAE. And so how do we think about this? I will say what we've seen is a huge interest based on the student applications in MAE, in mechanical aero. Just so you know, we're looking at starting a new nuclear engineering, a bachelor's of science. So we anticipate we're going to see a ramp up with that. Hopefully that'll go to the state for approval this year, this academic year. So this is where the students are demanding, this is where the demand function is. The companies, we have not had difficulty so far for our students being placed in companies when they graduate in MAE. And so the demand is actually matching the need. So this is a good thing. But the things we have to think about is how do we provide more students experiential learning experiences? We want to take them, especially in certain disciplines. The theory is great. The theory allows them to think and innovate, but they have to get that hands-on experience. So how do we have more of these opportunities for students? How do we provide even more immersions in companies so that when they are graduating, they can say, not only do I understand the theory behind dynamics or mechanics or circuits, but I also know how to apply it. So when they go into the workforce, when they go into your companies, they are actually dangerous because they can create, they can produce, they can innovate. And so we're working around that. Everything from if you're doing a capstone design your senior year, with this many students, where are they going to work? They have tangibles, they have gadgets. Something as simple as that. You're like, well, you just have them work in the green. So these are things that we are continuously thinking about, trying to get ahead of the demand function. On the other hand, computer science has decreased. And so a lot of times, if any of you actually read things like the New York Times, Wall Street Journal, there's been a number of recent articles that have talked about computer scientists graduating and working at Chipotle, or computer scientists graduating and having no jobs. And so the fact is that in some cases is true. What we're seeing is that a lot of the entry-level coding jobs are not being offered at the same rate. A lot of it is because there's a combination of basically the tools that allow AI tools that allow you to do at least entry-level coding. And so the jobs that used to be had, they're not as plentiful at that entry-level position. Now, if you have experience, you have the 5 or 10 years of experience, that demographic is not being affected as much. So what does that mean? The students, again, the demand function, I go to college because I want to be trained for the jobs of today, but also the jobs 5, 10, 15 years from now. And if I don't think that there's going to be a job in 4 or 5 years after I graduate, I'm going to go toward another degree, which is why I think also MAE has risen because, I know there's gonna be a job in that field. I know that you can't have robots and AI build stuff if it's in the physical world, not yet. And so I think some of that demand function is because they're looking at what's happening in the world right now. And so what we're doing in computer science is thinking about how do we provide them much more engineering experience with that computer science background. So that when they are in the world, maybe they're computationalists, but they're a computationalist plus something else, and that else is something that can't be replaced. And what is that? So computer science is actually looking at thinking through what does that mean? Because I anticipate that this is, and just so you know, this is a national trend. It hit us a little bit more than I had anticipated, but this is a national trend that computer science interest is going down, but we still need computer scientists in general. Now, the other one is ECE. Believe it or not, this is not a national trend. It's a trend here in Ohio, at Ohio State in the Midwest. And I think it's because there's been a lot of marketing around the semiconductor industry. We've been inundated with things around the plants, bringing manufacturing back to the shores. And so I think we have been just at a great advantage to say, and we are revising, we are adapting. In fact, there was a report recently that was released, and this was a report that was provided to some of the legislatures that mentioned the semiconductors, Silicon Valley semiconductor for the Midwest. And it talked about as being adaptive, open, and changing with respect to workforce demand. So what ECE did is that they looked at the curriculum and they developed a sequence of certificates that address different elements of the workforce needs in the semiconductor domain. And they also made so that we didn't have the chain of prereqs that we typically have. These are upper level courses. For most of you, engineering, to take an upper level course, there's always a sequence of courses you have to take in order to have the basic knowledge to be effective in that course. They actually stepped back and looked to see, well, is this sequence of courses actually required? Or is it just that we inherited this and we just keep going? And so they really rebooted looking at their courses to say, well, what's the level of math that you really have to have? Are there equivalent courses that allow you to get that basic knowledge in order to be effective? What's the basic elements that you need to have in some of the lower level courses? Do you really need to have circuits for ECE? Circuits is a requirement. You really have to have circuits if you're thinking about process management. Not quite sure, but let's look at that to ask that question. And so now they have a number of certificates that are open and available and accessible to basically any student that is a STEM major. So they did figure out that some of the basic knowledge that is required is that you have to have a strong foundation in STEM, but that does not need to be in ECE, that does not need to be in EAB. You just have to have some basic things around the math, the physics. Some of them require chemistry in that regard. And why I know it's positive is that it appeared in a report that was shared with the state that we did not provide input on. So this was an assessment from outside. So ECE, I anticipate a continuing trend in this, which is actually really good. Now, with the numbers, though, the things that keep me up at night is that our retention rate, which was on a steady trend, steady rise. We've been intentional about how do we scaffold learning for the students that come, how do we think about living learning communities, how do we provide academic advising, all the things that we have been piloting for the first 2 years of my term. It actually had launched almost at scale, but that scale was based on our traditional 1,600 students that enter every year. And so what we actually had an impact. So last year we had too many students in terms of our model, and we had to train them. And we basically had 2 months to figure out how we train 400 plus more students that we hadn't anticipated for. And what has resulted is our retention has actually gone down. And if we think about this year, we have even more. The positive is that we have lessons learned because we were band-aiding everything last year, trying to figure it out. Our ratio of academic advising, typically we like to go from 1 to 300. In some departments, it's 1 to 500. Students were just trying to figure it out on their own. We're now hiring academic advisors. We have now support from the provost's office because when our retention numbers go down, the entire university's retention numbers go down. And so now there's investment to actually try to resolve this. So positives of enrollment going up is that we provide the workforce that the need that companies want. The negative is if we don't retain them, we don't provide the workforce that is needed. And so this is what keeps me up at night right now is how do we get in front of this for this next batch? And we have a plan. But these students are now entering into their discipline-specific courses, mechanical being one of them. So how do we work with them? So we've been for the last year working with the departments because we saw the demand. We knew that they would be coming to the departments in a year. What is it that you need? How do you have to hire lecturers? What can you do with respect to academic advising? So I anticipate that we're good for this year, but the next bottleneck will be capstone. How do you now do, these core group teams that actually have great experiences when we don't have that many more instructors? We can't hire that many more instructors. So how do you still have that same quality while knowing that we have a lot more students? And so we're now looking forward, how do you address this? How do you address this? Always looking forward for ensuring that student success is optimal. But this is what is keeping me up at night right now. So other strategic initiatives that are going on. President Carter had a state of the university address where he outlined a lot of these. I will say engineering was prominent in a number of those. So one was an education for citizenship strategic plan. Part of that is thinking of how do you invest in student success so that they are not only great citizens of society, but also of companies. And so part of that is he announced investments in 6 colleges. 3 of them are the professional colleges, so law, vet med, nursing, and 3 of them are around undergrads, which is arts and science, business, and engineering. And what investment looks like is how do you ensure that you have more students, you retain them at a high level, and you graduate them in record time. 4 years, but we push back into 4 years because engineers don't tend to graduate in 4 years. But also ensure that every student has an experiential learning experience throughout their entire career. So it's not just, I did one summer intern, it's how do you integrate that in the curriculum? And he's also providing resources for this. So we're now trying to plan around academic advising, experiential learning. How do we recreate our first year engineering program where experiential learning is embedded in that? So when a student comes from high school, 18, 19-year-old, lands in a class, they're already applying engineering knowledge that they didn't even know to real world problems of consequence. And so that is part of it. The other great initiative is around the AI initiatives, which is AI fluency. The entry class of freshmen will be AI literate by the time they graduate. And the definition of that is basically every year they will have some touch point in their discipline around AI. And for all the departments, we are required to look at the entire curriculum for that discipline and figure out how do you embed AI knowledge within it. And it could be a string of pearls. So it could be, well, this is a sequence that all students in aerospace take. And so we're going to embed modules in that string of pearls. Or it could be that the students take a certificate in AI and then apply that certificate knowledge to their capstone. So we're actually trying to figure out what this looks like, and our plans are due in November around what does this look like. I will say the plans are very much like 99P. We will submit, we will look at it, we will revise because it won't work. It's a plan. First contact always fails. We will revise and we'll continue doing this until we actually have something that works for all the disciplines. And then the AI Hub is a research center that provides the infrastructure around AI. So a lot of times, some of the research says, I want to use AI tools, I have data, but I'm not an AI expert. So the AI Hub is really a convening of all of these things. Went out. All right, there we go. So the AI Hub is a convening of the infrastructure that is required for researchers to implement AI in their research. It is everything from actually data scientists that are hosted by the hub to researchers that can be embedded in a project to I'm creating a grant and I need to understand the tools associated with medicine. The hub is to provide that. And so it really is a resource that will be provided to all centers, all researchers, faculty, departments to really accelerate the immersion of AI and AI globally could be anything of the tools into our research enterprise. And I will say this is being led by one of our own, a faculty member who is in ECE and CSE. And so we will move on. Part of this initiative, which I'm excited about as a dean, is that there will be 100 new faculty hires that will be allocated across the university. And the only requirement we have with respect to that is that they have to be part of this infrastructure, this AI hub infrastructure. But they will be supported based on salary and startup for the first few years. And it's irrespective of the discipline, but they have to have a focus on AI. So it means all of my departments can actually go for a faculty hire as long as they're in, they could be in energy and AI, they could be in automotive and AI. So excited about this. It's 100 new faculty hires over the next 5 years. And so we just kind of baseball knowledge is that we took most of our open positions and added in the language of AI so that if we do have a great person who is in semiconductor that happens to also be in AI, we can capitalize on this hub. And if not, it's still in there. So we basically are being overly cautious so we can grab at least some of those 100 new faculty lines for our current open positions. And then related to CAR is there's a focus on growing the research enterprise to 2 billion annually. So they just hired a new VP for research, which also is one of our own, and John Porat, who is going to focus on how do you grow the enterprise, given that we also still have these constraints, but there's these pockets of funding that has increased. And so how do we do more? For example, a Department of Defense funding has actually increased. I will say at Ohio State, we do not grab this equivalent of funding in DoD type of research than some of our sister universities. So how can we do more in, say, that space? And so the new VP for research will be more strategic around this is a federal funding landscape. How do we compete in these areas and continue on? What I will say, which is a testament to those in this room, is we do really well in terms of industry-sponsored research. We've done very well. And a lot of that is about having a relationship and then delivering in this collaborative experience, collaborative way. And so I think that will help us accelerate some of this getting to 2 billion annually in this aspect. On the college, some of our strategic initiatives is the Gateway to Engineering, which opens in February of 26. And that will house all of our first year engineering programs. I always define it as it's the Disneyland of engineering. It has maker spaces. We're trying to figure out how do we have robots go in the hall with the students. It has configurable classrooms. And it really is to bring in the first year students and actually show them that this is engineering. This is your experiential learning experience. This is what it looks like. And then you go into the discipline. And so the first contact for all students in engineering should be this lovely Disneyland. And then you get into things like dynamics and thermodynamics. And they're like, oh my gosh, but I remember my Disneyland experience. And so we really want to capture them as an audience and then send them back out to their disciplines. The other is the Center for Computing Education. I mentioned this AI fluency initiative. So one of the things we wanted to do was provide students in all of our departments, and as well as other colleges, the ability to be fluent in computing and in AI. And so the Center for Computing Education has launched the first set of courses. Has launched the first set of courses that allows students who are not computer scientists to actually evolve and get the basic computational skills, data analytics skills, and AI skills at any level. And for this one, we can even take a student who's in humanities and actually grow them and educate them so they will be knowledgeable in terms of computing and AI skills. So we've offered the first set of courses, 3 courses for undergrads. They're now looking at expanding that to graduates. So we've heard from graduate students that at the universities as undergrads, they didn't really have the ability to engage in AI or computer science. So we're now taking our courses and creating graduate versions of this so that now graduate students can be trained in computational skills as well as AI. And we have a model, we've been very intentional on this model that it doesn't increase your time to graduation and it doesn't increase your cost of attendance. And then the last one is we are looking at, we have a Center for Aviation Studies. We are now in the process of converting that to a Department of Aviation. What that looks like and how I describe it, it really is more around applied aeronautics. And so the students in the curriculum will look at such things as eVTOLs. They'll look at how do you do logistics support for thinking about aircrafts and the flights and FBO, the actual airport structure. And so it'll be basically this applied version of aeronautics, and also will lean into all the things that we don't yet know about. What happens when mobility changes for the air? Are we prepared to teach our students what this looks like and has the skills? And so they will create a number of courses that will allow students the skills to think about what it looks like when you have your own personal hovercraft, which will happen, but it may not happen in 5, it might not happen in 10, but our students graduating from the department will be able to do that. And so the Department of Aviation will work closely with MAE because of that intersection of aerospace engineering and now aviation engineering. And with that, I will open it up for questions.
Sorry about that. Any questions for Dean Howard? Yes, David.
When I first met you, we talked about the pre-engineering and how to get it so the third-year students aren't getting kicked out of the department. I noticed the numbers were going down on some of them. What changed?
So one of the, so we used to have pre-majors. And so pre-majors was students would get admitted into Ohio State, but they were pre-major mechanical, or pre-major computer science, or pre-major chemical engineering. So one of the things that we did is 2 years ago, we had no pre-majors except for 4. So when students were admitted into Ohio State, they were admitted into their major. They could change. So I might have thought I wanted to be a chemical engineer. I took my first year engineering and I'm like, oh, I really think I want to be a material science. We still had the 4, which was mechanical, aero, biomedical, and computer science. What Rob Siston did for MAE is every September, he would take all the pre-majors and admit them. That was part of our testing of what was the pain points, what were the limitations, but he was willing to figure it out with me. That was a great test pilot. It did not break. And so next year, just so you know, next year we will have no more pre-majors. So every student that gets admitted to Ohio State, that gets admitted into a department, gets admitted into that discipline, and we will allow students to change majors as well. The other caveat is we will allow students from other colleges to move into engineering.
Congratulations on that. That's awesome.
Really, really well done. Nick, a quick question.
So it looks like undergrad enrollment is expanding massively, but doing some math in my head as you were going, it looks like graduate enrollment is that big. For 2025, there's probably an obvious answer. It looks like it's been trend. Good question.
Yeah, so if I separate graduating, our PhD student has actually, PhD student numbers has slightly increased. Where we have the biggest deficit is in master's students. We have not recovered from the things that happened in COVID. And now I don't know what we're going to do with respect to our international population. But one of the things that we've been looking at, and this is being led out of Associate Seth's office, is we don't do a really great version of converting our undergrads to graduates. And so we're gonna host, starting this summer, a summer REU, where we're going to pay undergrads to stay here and work with the faculty here. We're also going to this experiential learning. We don't tend to give credit necessarily, course credit for doing research. The university wants experiential learning. They've agreed that research is part of that. And you have to be able to claim that you've done it. And so we're gonna have a little bit of a forcing function to get students. I truly believe that once undergrads get a taste of research, then they're like, oh, this is like really great. I get paid to have fun. And we just don't do a great job of that. And so we have a number of programs to then at least convert them home to addressing that.
Thank you very much. Let's thank Dean Howard. Fascinating.
bugs today. There's no IT bugs left.
And I'm telling you, those numbers were fresh. I hadn't seen the last ones yet. So I'll take just a few minutes to give you a quick overview of where we are. We are a little bit past our agenda, but we'll make things work. So we always report on new hires. CAR has always been very dynamic in its staffing, and we're very pleased to welcome Danielle Shank as Associate Fiscal Officer. Danielle is relieving Meg of many day-to-day responsibilities. She's been with us for a few months, and we're delighted to have her in that role. Each of you should see an annual report in front of you. Take it with you. It's fun reading. We try to make these things not be boring lists of facts and figures, lots of images. But some of the things that you will see in that annual report are that things are going well. We continue to have substantial numbers of collaborators. This past year, 49 faculty across different parts of the university collaborated with us. We have had in the past year 27 visiting scholars. We continue to be a place where people from all over the world come and share time with us and do research with us. Altogether, our total expenditures last year were close to $20 million, of which $14.5 million was externally sponsored research. You saw the numbers from Dean Howard, so you can think of this 14.5 as being a percentage of the total College of Engineering research expenditures. We're one of the pieces that makes the college successful. And you can see, if you look at our 5-year trend, that we recovered reasonably well from the difficult pandemic stretch. 2020 and 2021 were difficult, but we are generally speaking doing well. Some programs ended. A couple of major programs from the state of Ohio and with industry partners ended. We are moving on to new programs. Did we lose the mic? Okay, good. Thank you. Thank you, Lance. So we continue to have sizable numbers of students engaged in our activities. We've actually employed 123 students in the past year, and that means undergraduate research assistants, master's and PhD level students. We also, when we can, recruit high school interns. We are deeply engaged with, on one hand, the motorsports teams, and you'll hear a lot more from them today. But we continue our camp car, an opportunity we offer to high school students. We had 100 applicants last summer. We're limited in what we can do. It's a very special program, but we had 26 high schoolers. And the number of those, if you look back in years who then end up becoming engineering students at Ohio State, is significant. We like to collect data on our tours because it turns out that car is one of those stops on campus that people like to make. We host visitors all the time. Last year, we had 180 distinct events that touched almost 9,000 individuals. So it's a pleasure to be able to share some of the things we do with the larger community. I mentioned Camp Car already. That's always a big success. And we have a summer internship program where we bring in people from our own student population as interns, high schoolers, and students who come from other universities as well. One neat thing that has happened, and you will hear a little bit more about it next time in 6 months. We have a new partnership with Professor Jana Hauser from the Department of Geography. And we are in the process of helping her develop a radar system, a movable radar system with support from Raytheon's Collins Aerospace. And the idea of this is to create a capability that will collect data on severe weather conditions. So Jana Hauser is one of those tornado chasing people. She does it professionally, has a substantial amount of funding for her research, and we're pleased to help her with the vehicular side of it. I'm not so sure we're going to go chase tornadoes with her.
We're giving you that.
You'll probably make it. Okay. All right. And this was really my flash, very quick overview of things that are happening at CAR. I would say that generally speaking, at the moment, things are looking good. We are a reflection of many of the things that Dean Howard mentioned with respect to the college. We're currently in a fairly steady state. We don't foresee any difficulties in this coming fiscal year. We'll have to see what time brings, but I can tell you that we are as busy writing proposals of all kinds as we've ever been. So our outlook is positive, and I think the history of doing research in this world of that caters to the automotive and transportation industry is full of ups and downs. I know that many of you have been in this world for a long time. We'll find a way to navigate the current circumstances as well. But for the time being, I think things are looking quite good. Thank you again for coming. And at this point, we turn it over to our brilliant students. And David, if you don't mind being master of ceremonies for this, I'll turn it over to you.
Definitely one of our favorite parts of the year. For the next segment, we'll hear from each of our motorsports teams on what they've been up to for the last year and what they're going to do next year. Before we jump into that session, we want to take just a moment to invite you all to an event. If things work out well, you probably should still or should already have this in your email inboxes. But in case you don't, we're going to be coming north for those of you in the greater Detroit area. I'm very, very excited about a special event. I'm going to talk more about it this afternoon. But in case we lose a couple of you, just wanted to make sure at the beginning of the meeting, you saw this and are aware. If you are not aware of this event and are willing to travel to the greater Detroit area, we're going to be at the Pontiac Transportation Museum. Let David Emmerling or myself know, and we'll make sure that invite gets forwarded to you. But CAR will be coming north in partnership with Jobs Ohio. We'll be putting on an event talking about where the industry's headed, some of the things we're doing. We'll be bringing up all the students and student projects and talking about our next round of investments and some pretty cool stuff that we hope to do at CAR over the next couple of years. So you are all invited to that event. But with that, we'll get into our student updates. And up first is Buckeye Solar Racing.
Oh, thank you. Yes. So my name is Demi Sia. I'm a senior in mechanical engineering here at The Ohio State University, and I currently serve as the president of Buckeye Solar Racing. So a little bit about our team. As an organization, Buckeye Solar Racing aims to design, build, and race solar-powered vehicles in all levels of national and maybe even in the future international competitions. I have a little bit of history about our team is that we were started in April of 2021 by a handful of inspired and ambitious engineering students. And we also, as an organization, hope to provide students with the opportunity to gain both technical engineering knowledge, business expertise, and also project management experience. And we hope to do that all while advocating for the use of renewable energy. A little bit about our team structure is that overall we're split into 4 sub-teams. So that includes our business sub-team, our structural sub-team, our electrical sub-team, and our aerodynamic sub-team. And as part of that, I have under me 6 sub-team leads, 14 project team leads, and over 50 members in total from, I believe, around 3 different colleges. Our founding organization is the Innovators Educational Foundation, whose objective is to engage young minds with the hopes of developing more world leaders to develop better solutions to society's challenges that are faced in the US and around the world. And also, again, to provide unique learning experiences that challenges students from higher education to develop design solutions that help address areas of energy management, transportation, and high-tech materials. A little season recap is that in solar racing, our main 2 races are the Formula Sun Grand Prix and the American Solar Challenge. So the Formula Sun Grand Prix is a 3-day track racing event, happens on a closed loop race track. And prior to that, we have a 3-day scrutineering period where you compete to see how many laps you can complete during the same time. So I'd like to say one interesting thing about Buckeye Solar Racing is that we don't actually compete in speed, we compete more in efficiency. So all teams get the same amount of time to race, but you just see how many laps you can complete. So it's more of an efficiency challenge. The American Solar Challenge race, which is the level up from that, is an 8-day, 1,500 to 2,000 mile cross-country endurance rally, where teams race across the open roads of the United States and try to cross the nation in as fast as possible. And a little season recap about our last year is that we were able to finalize our aeroshell design, modeling it through CATIA, and we also were able to test it using wind tunnel testing and a kind of smaller scale model. We were also able to design, validate, and manufacture our chassis and roll cage. So we did that through SolidWorks ANSYS for finite element analysis. And we were able to weld it completely in-house by undergraduate students who did not know how to weld before we took on this challenge. We also mainly focused on raising funds in preparation for this school year. Our new car is going to be made completely from scratch, so we knew we would need a lot of funding to help make that work. And in addition to that, in order to prepare for manufacturing our new car, we focused on teaching students welding and machining skills, including lathes and the mill. And last but not least, we also really focused on improving general team documentation and organization. Coming from a relatively newer team, we wanted to continue to make steps in all areas that would help us create better and better cars over time. Some of our goals for the upcoming year is to finish manufacturing Surya, the new solar vehicle. So Surya is the name of a sun god in Hindi, just a fun fact. And our main bucket list, our ticket items for that is to fabricate the entire 19-foot by 5-foot by 4-foot aeroshell out of carbon fiber. And for that, we're currently looking for a company to CNC the tooling board into our aeroshell's female mold for that. Pretty hard to find somebody with that big of a CNC. We're also looking to manufacture our entire custom suspension in-house using CNC machines that we currently have and with undergraduate students, which is quite a big task, especially considering the amount of time and money it takes to train students. So that is one of our other main ticket items. We will also be purchasing and installing a 6 square meter solar array that will power our 5.25 kilowatt hour battery pack, both of which are new requirements from the previous years. And then after finishing manufacturing our car, we hope to successfully race it in both the Formula Sun Grand Prix and the American Solar Challenge, of which we've never been able to race in the American Solar Challenge before. So that is our goal with our new vehicle this year. And in order to make that work, we're really focusing on being able to frequently test the vehicle during the spring semester, work out all of our bug fixes with our electrical system, make sure that our vehicle can pass all of the dynamic tests, all of our figure eights and slaloms and such. And then we also hope to collect data to develop race strategies on most efficient drivers and most efficient speeds, things like that. And then continuing on, we're continuing to improve the team structure and organization. As our team grows larger and larger, we've realized that some of our previous models could use like some more development. So we're always focusing on developing how we kind of structure ourselves as a team. And we also focus on documenting all of our design and manufacturing decisions and rationale this year to make sure that future cars will only continue to get better and students will have to go through the same maybe struggles that we did. And then, of course, we'll be collecting data and metrics for use in developing the next solar car to understand how our weight and our track width and all those metrics impacted how we did on the race. That was all I had. Thank you.
Really impressive on top of all the great work that they're doing. That this is really a fairly new team that started up just a couple of years ago. A lot of the teams that you'll hear from today have 20 to 30 years of experience, tools in the shop, software tools to build upon, but they've really launched a whole new initiative from scratch. So it's been really exciting to watch, and we're definitely excited to show you the new car here at the next time New York Cars. And speaking of new teams, up next, the Battery Workforce Challenge, also one of our newer competition teams, just 2 years in, but really functioning like a startup company, creating an entire ecosystem to design and build and implement battery packs. Again, starting from scratch just 2 years ago. And so been really a pleasure to watch the team as they've matured immensely. So Neha, if you join us.
So I'm here to talk about Battery Workforce Challenge team, and I'm Niharika. I'm the software lead for the team. Speaking a little bit about what Battery Workforce Challenge is, it is an advanced vehicle technology competition that is held by ANL, the Department of Energy, and Stellantis. So together, we have around 12 teams that compete across North America, and our agenda is to build an entire battery pack from scratch. So we've been given a bunch of cells from Samsung, from which we design our entire battery pack. We design the battery management system, and we also make our own battery pack from scratch with these components, and this allows us to create something that we can remove from the original Stellantis vehicle that we've been provided and put in our own creation. So this is our team. So we have around 5 leads, and we have 5 subdivisions. So we have project management, mechanical engineering, electrical engineering, and software. So I'm the software lead for this. And another thing about this competition is that all our teams are in tandem with another community college that allows us to work with technicians and improve our skill on that arena as well. And these are our advisors. So we work with Dr. Dartino, Dave Cook, and Ian Andrews from CSCC. And also we have some mentors from Stellantis who help us develop our ideas and to also make sure that we get our deliverables on track. A little bit more about how our modules are coming across. We have a timeline of around 3 years to build this battery pack. So this means that we move step by step to make sure that we achieve our goals of creating battery pack by the end of the year in May 2026. So to reach our goal, we make sure that we have around 15 modules built by the end of this year, and we integrate them and create this battery pack that meets the KPIs of the vehicle. So this is what our progress across the 3 years has been like. So the first year we spent in team building and cell characterization. So we actually understood what we're supposed to do. And last year we spent our time on creating a battery disconnect unit and devising our design for the modules, which are very unique to our own team. So every team has its own design and have their own plans on meeting those KPIs to make sure that the same vehicle runs in different ways. And we also had to come up with our battery management system architecture and our thermal cooling design plate. So what we did in the thermal plate was to work with many other teams to create a common cold plate that would let us cool the battery down. And this was a good initiative that we had with the company called Dana. And in our final year, we're going to be putting this pack that we designed, and this is our final year right now. So we're going to put a lot of our efforts into creating the entire battery pack, and we will be integrating this into the vehicle. So a season recap of last year was when we came in, second overall. We also won a lot of awards in the arenas of project management and module building. We also got awards on the software side as well as the thermal side. So we've got a lot of awards and we came second, but we're also going to be working on coming first next year. And this also comes with a lot of gates that we need to pass. So the competition has designed a bunch of gates for us to pass to make sure that we do hit our goals. And you can see it's split into 3 different fields. So the video has to cross 3 gates And once we finish each gate, we're able to move on and complete our entire vehicle system integration. And the hardware has around 5 gates that we need passed, and software has 2. So we have different teams working on making sure that we can achieve our goals within their recommended dates. So we're able to actually complete the whole pack design. And understanding that this is a lot to do in a short timeline, we're very pumped to do this. So that's all I have. I'm glad you want this challenge. Thank you.
The margin between second place and first place could not have been closer. But I have to say that Narika completely swept in her area. So she created the entire hardware in the loop bench to demonstrate the BMS capabilities. And they did it sort of trade fair style. She had 20 engineers grilling her for 25 minutes. And jaws were dropping. She just did an absolutely phenomenal job on one of the areas that brought us up in the points. But we were just this close to first place, beat by a Canadian university. I campaigned my hardest to apply a tariff to their points and just bring a couple out, and they told me that's not how that works. I don't get to apply it and profit from it, so I was very confused. But next year, in year 3, we're coming for them. So up next, Buckeye Autograph. So David, take it away.
Thank you. Good morning, everyone. My name is David Allen. I am the team captain for Buckeye Auto Drive. I'll tell you a little bit more about what we do, what we've been doing, and what we're going to do this upcoming year. I'm also lead for our vehicle integration team, which, if you're coming from industry, which all of you are, that is actually what we refer to as our CAN and human machine interface team. I know that means a very different thing in industry, but a little bit about us. Buckeye Auto Drive is one of 10 total teams throughout the US and Canada. There are 2 Canadian teams, which are doing the Auto Drive Challenge 2 competition, which is primarily sponsored by GM and SAE. And the primary objective of this challenge is to take a stock Chevy Bolt EUV and transform it into an SAE level 4 autonomous vehicle that can navigate urban courses as described by SAE J3016 level 4 automation. And a little bit more about our team. We are primarily an undergraduate competition. So we are primarily made up of undergraduate students in electrical engineering, but we also have plenty of other students from various majors. We've had math majors, actuarial science majors, lots of computer science, of course. And we also have a good mix of master's students and PhD students to help the undergraduates grow and do their best work. We are also what we kind of like to call ourselves co-opetition as opposed to competition, because, you know, for many other motorsports teams, the goal is to simply do the best and obliterate your opponents. But for us, we have our workshops throughout the year where we go and meet with our industry sponsors as well as other university teams. We discuss our systems, talk about advice for how to make each of our systems better, so that all of us, when we go to competition every year, we all have the best possible vehicle that we can produce. And this is also a great a great networking opportunity for us to talk with people from other universities, as well as our industry sponsors. And the primary learning objective of our competition is to empower undergraduate students to become engaged and interested in joining the automotive industry, and particularly in the field of advanced driver assistance systems. And we actually get to implement these with real industry grade hardware on a real physical vehicle, which is also really cool. So a little bit of a recap from our past season. You can see some of our past efforts. We had some presenters at the SAE World Congress last year. We also got to do a presentation at competition, showcasing some of our autonomous systems. I think we focused on our sensor stack and our HMI last year, so human machine interface. And then we also designed some custom hardware to drive that HMI. We call this Polix. And you can also see that we were able to win some awards last year as well. So you can see me accepting our 3rd place in mobility innovation. And then a little bit more about last season. We greatly enhanced our vehicle's capabilities by focusing on, we have our primary localization, which is primary GNSS. And we have since learned to develop our secondary localization systems further. so that when we're in GNSS denied environments, such as tunnels or mountainous areas in general, we can still have the vehicle localize and navigate through those environments. We also took on the role of a robotaxi, something like you would see with Waymo and Cruise, and we're able to use that to navigate through a closed urban environment for us. And then we also presented and proposed an optimized sensor suite, particularly for the scenario of automatic emergency braking in adverse weather conditions, such as rain, sleet, snow, and fog. And with last year, we were able to receive third in mobility innovation, as you saw on the last slide, and third in the MathWorks simulation challenge. Then some of our goals for this upcoming year is to further improve our human machine interface to visualize the vehicle trajectory as well as objects that the sensors detect. Something similar to like what you would see in a Waymo, for example. We're also focusing on getting our vehicle up to something that you would potentially see in a real industry production vehicle. So a lot of that is streamlining the user experience as well as the physical integration of our systems into the vehicle. So we're doing that by like improving the thermal management of the compute stack, because we have a very large server in the vehicle, which gets very hot very quickly. So that's a really fun challenge to deal with. And then we're also working to better physically integrate our HMI into the vehicle, using 3D printed enclosures, larger screens, things of that nature. And then our more overarching goal is, because this is our last year of this competition, we are trying to achieve SAE level 4 autonomy. And the way that we're doing that is by increasing the robustness of our secondary localization systems so that we are even more resistant to GNSS denial, and also increasing the vehicle's resistance to environmental hazards such as strong light, fog, and sand, which can interfere with sensors. So it's something that we have to compensate for. And we are also validating our vehicle performance by testing them on these actual edge cases. And then I have some graphics to kind of demonstrate that. So you can see one of our challenges is we have to be able to still navigate even if there is sand on the lane lines. So I have a little graphic there for that. You can see strong light sometimes can cause a bit of a glint or like lens flare on sensors. So we're also navigating around that. And you can see I also have a picture of, I think that's Waymo's HMI system. That's something similar for what we're going for our vehicle for our visualization this year, and then also driving through a tunnel. That's all I have.
Thank you very much. Jack, come on out. Up next will be the Formula Buckeyes program.
Alrighty. Hello, everybody. My name is Jack Bales. I'm a second year aerospace engineering student. I'm the brakes and ergonomics lead on Formula Buckeye. So today we're just going to be talking over a little team review, a recap of our previous seasons, and then the planning as we move forward to our next years of EAB and our EV design. So what we do, we're one of the longest standing project teams here at Ohio State. We've been competing since 1998, as you can see, one of our first internal combustion cars from 1998, all the way to our first electric vehicle in 2024. So our competition is broken into 8 scoring categories, 4 static events and 4 dynamic events. Our static events include design. This is the scrutineering of our car, seeing if we can justify our design choices, what we chose to do on our car. We have our cost breakdown, how expensive our car is. We fill out an annual cost report, and then we present that to our judges. We have a presentation. This is a business presentation where we're given a business case and we present it to a panel of judges. And then we have our efficiency. This is the overall ability of how well our battery pack can hold its charge throughout the course of the endurance race. And then we have our skid pad. Our skid pad is a constant radius turn, testing our steady state performance. We have our acceleration, which is testing our straight line performance. It tests our aerodynamics package, our power. And then we have our autocross, which is a single lap around a cone track. And this is to place yourself for your endurance race. The endurance race is 10 to 20 laps. That's a cone predetermined track. It takes about 26 minutes and it's split between 2 drivers and it's scored based on the total time it takes to finish all laps. So who we are, we're primarily an undergraduate team split between mechanical and aerospace engineers. We've seen a large increase in the number of electrical engineers since our change to EV last year. We also include a lot of computer science majors and a lot of finance majors to run our business team. This spread of majors and engineers has allowed us to have our largest recruitment class ever of over 250 students, which split between 11 sub-teams with 25 leadership positions. So our season recap. Our season, we split between three sections: our design section, our build section, and our testing phase. All of these, the design phase, we finish around mid-October. And last year, we were able to successfully design all aspects of our car, from our chassis to our accumulator or battery pack. In our build phase, we were able to build all mechanical aspects of our car. However, we were not able to successfully build our battery pack. We knew this kind of going in. It was our first year as an electric vehicle, and we realized just how difficult it was to make the change from a running IC car one year to a running EV car the year after. Almost no team in FSA history has been able to successfully make that change. And our team knew this, and we showed a lot of passion to get to be able to change that narrative and actually successfully be able to have a running car throughout the year. And then our testing phase. So although we didn't have a fully running car, we were still able to test the mechanical aspects, the chassis, the suspension, and the aerodynamics package on our car. We were able to test that, and we'll use that in future years to validate our future cars. So our competition results. As I said, we didn't have a battery pack, so we were unable to race in any of the dynamic events. However, we were still able to come in 3rd place for our business presentation and 47th place for the design presentation. And that gave us the 37th place overall out of 120 schools in our first ever year as an EV team, even beating out 4 teams that actually did compete in the dynamic events, just showing how important those static events are for us. So our goals for the upcoming year. Our primary goal is to pass the technical inspection. This is the scrutineering that goes into seeing if your car is able to participate in these dynamic events, if it's safe enough. And we realize that if we're able to pass this technical inspection, we will be able to successfully, we believe, place top 10 in EV based on how well we performed in those static events last year. If we have a running race car, we can open up to almost 50% more points, which would be able to just drastically increase the amount of points we can totally get. And then another big goal for us is knowledge transfer. We are a very young team, and again, this is our 2nd year as an EV team, and we just realized how important it is to teach the future generations of this team. And we realized that everybody who is in leadership right now didn't know how to do what they're doing when they joined. And so we realized how important it is to make sure everybody on the team knows what they need to do and learns everything that they need to learn, because at the end of the day, that's the goal of this team. And then successfully build and integrate a battery pack. Last year, we were so close to being able to compete, and this was the one thing that was holding us off. So we're placing a large priority and a large emphasis on the creation and completion of this battery pack. It was the one thing holding us back, and we're not going to let that happen for 2 years in a row. So our EV redesign, as you can see on the left-hand side, that's our budget for the upcoming year. Last year, we spent a little over that amount of money. We had to buy our new AMK DV5 motors. We run custom firmware on these motors, and on our car, they are able to produce over 20,000 RPM. And with our custom gearboxes, which are 14.14 gear ratio, we're able to produce a large amount of power from this. We realize that this budget is large for most teams, and last year we even spent over this budget. And what we're doing this year is we learned more about how to budget and how to consolidate our money for the realm of EV cars. And we're going to stick to this budget and not go over budget this year. Hopefully, we know how to spend for EV, and we're going to make the change to make sure we can not go over this. As you can see on the right-hand side, we have our 2 future years of cars. We have So our next year, our plan is to go to 4-motor drive with 2 in-hub motors, and then our 2 rear motors staying in the same location inside the chassis. This is just to simplify it. We don't want to throw all our eggs in one basket and try and go to 4 in-hub motors before we even know how to do an in-hub motor. So that's what our design philosophy is, to kind of take it one step at a time. Right now, our philosophy is walk, then run, then sprint. We don't want to start sprinting now. We want to slowly build up to this. And this is just kind of aligned with our passion and our desire to advance as a team and become better and better in any way that we possibly can. There's a QR code up there. If you have any questions, you can scan that. Thank you all for your time.
Much. Yeah, the transition from internal combustion engine to EV and the complexities there, not the under to all of you now, but they've had to do it in real time. They've really done things in a certain way for 30 years, and they figured out most of the car had to be completely redesigned. Those numbers you saw for student engagement is real. This team has done a phenomenal job. It attracts a lot of attention, but actually interacting with hundreds of students and maintaining them throughout the year is a big challenge. As they were transitioning to EV, I requested to meet with the team leads on a regular basis and help to translate some of the knowledge from some of our other EV programs. And when they first invited me to a leads meeting and there were 25 people in the room, I said, you guys use the word leads in an interesting way. That's just the whole team. And they were serious though. They really broke into that many different subgroups and engaged teams to do R&D, process learning background, and have completely invented all new systems for the car over the last year. So really been phenomenal to watch, and we're excited to see the car on the ground this year and all the great things they're going to do. So we did hold questions during that section of presentations because we do have all the students here. Many of the cars are just outside, and we also have a lot of posters around the room. The students did a phenomenal job of not only getting us back on track, but I think 2 minutes ahead of schedule, so we can have the full break. We encourage you to grab a coffee and a snack and mingle throughout the room and see some of the different displays, and we'll resume here in about 20 minutes with the other half of the student presentations. Thanks.
So you can binge watch the whole documentary on our YouTube channel. Just look for Drive Ohio on YouTube. There's about a 17-minute full documentary. We're pairing that with curriculum for high schools. We're going to have 8 modules that'll be downloadable through the Drive Ohio Toolkit later this month. It's called Formulate is the nickname of it. And if you're excited about getting involved with K-12 students, the Ohio STEM Learning Network is sponsoring a statewide design challenge this year about electric transportation. Just go to osln.org/expert. You can sign up as an expert. You can answer questions online, do all that stuff. And I'm going to hand you the mic right after I announce Drive Ohio is doing a research roundup next door, October 28th. If you want more details, find us or check out our website. Thank you.
Thanks so much, Rich. Appreciate it. All right, we're going to continue with the student presentations. Lily will join us from Buckeye Current.
Good morning, everyone. Hope everybody can hear me. I'm Lillian Steevely. I'm representing the Buckeye Current team here, and I'm the executive officer for this upcoming academic year. So I'm sure many of you know, but I'll give you a little bit of background about the team. Buckeye Current is building a land speed electric motorcycle to race at the Bonneville Salt Flats. The team was founded in 2010 and historically raced in ECTA, Isle of Man TT, and Pikes Peak. A little bit about our team demographic. We currently operate the general body under 6 sub-teams. We have aerodynamics, battery, business, chassis, powertrain, and systems. Within the group of our students, we have 7 majors represented. We have engineering majors such as mechanical engineering, aerospace, civil, electrical, computer, and industrial. We've also got an air transportation student, and we've actually got a high school volunteer. All of the students within the team are undergraduate level. We have students from 1st year all the way up to 5th year. And again, we have our high school student who's also on the team. A season recap. The team made a decision last year to take a year off from racing to further the education of our team members and the research into the changes we were making. A recap of what we did during that season. We did some reverse engineering and in some cases re-engineering of many of the bike components. We obviously reached out to alumni who made some of those fundamental decisions that really nobody on the team currently made when the bike was first being built. One of the key things we did was tracked and documented our wire harness connections. On the previous iteration of the bike, the wire harness was maybe a little bit messy, especially because the team was trying to reach the deadline of going to the Salt Flats. And so over the summer and into this semester, we worked through tracking, all of the connections from our VCU to our motor to our battery, to understand, especially when we're reading data, where are the numbers coming from. Another thing we worked on was improving team education in the battery design process. Going back to what I mentioned earlier, nobody on the team was involved in the battery design at the way beginning. And so understanding why decisions were made and how we came to where we are now is really important if you're making changes. And that was a big part of the process and what we did last year. We also investigated the limits we faced during the 2024 races. We were very successful. We set our 4 world records and our 1 regional and national record. But we obviously faced limits in our system. One such limit was through our aerodynamic effects. We examined those on the fairings through simulation. We used ANSYS, and so getting some new members, some people who had never touched even SolidWorks before, to learn how to run a simulation and get some meaningful answers through it was really a big drive last year. Another thing we did was evaluate system efficiency. In that case, we noticed on the salt that we were putting a lot of power in, but we weren't getting as much out. And while no system is complete 100% efficient, there were greater losses than what we were expecting. And so understanding if components are clashing with each other, how can you integrate them better to, of course, have higher efficiency than what we were. We also developed test plans for a motor with a new internal configuration. One of the inefficiencies we suspected was because we had a custom motor with increased windings around the poles. And so we suspect that maybe there was some back EMF that was going back into the system. And so getting a new motor with less windings, we're looking to test that. Another issue we had was we suspect a broken bearing within a motor. We have not opened the motor and inspected it, but just because we're using to validate some other things. But another thing we're focusing on is adding some reinforcement to the bearing, both while we're testing and while we're on the bike. So going from what we did last year into our goals for this year, we're going to be putting those research and plans into action. First thing, one of the most important things we're doing is going to validate that new motor. We really want to build out that characteristic curve. We want to know, torque speed curve. We want to know constants of the motor, torque constant, back EMF constant, things of that nature. We also want to manufacture an upgraded battery pack. Due to not many of the people on the team knowing the fundamental design of the battery, a lot of the changes we're making are for safety and for serviceability. Currently, our battery pack is made up of 3 modules. Each module is 225 cells. So each module is rated for up to, I think, like 300 amps of current and 180 volts of, voltage. And so breaking each module up into more pieces, one, makes it a lot safer to work on. I don't want my team members to be working a battery, even with the proper PPE, and get hurt. That would be a huge loss, not only to us, but to car as well. Also, with 225 cells in one module, if you mess up one of the welds when you're putting on the bus bars, you can scrap that entire module. And not only is that wasted time, but it's also wasted effort and money. We're also going to be modifying our fairings for performance and ease of use. A big thing we noticed is our bulkhead, which sits around the front tire, is like a big scoop for air. And so air is just getting caught in there, causing a lot of drag when we're racing. And so developing a new bulkhead, which has more of a streamlined design and doesn't act as a scoop in the front, is a big driver of what we're doing. We're also evaluating a new front fender as well as a new windscreen. We're also manufacturing a new chassis component. One of the biggest ones we're doing is a swing arm. We currently are only able to run a pretty thin profile of rear wheel. And one thing we noticed when we were running unfaired without bodywork is that we were traction limited. And so being able to switch that rear wheel out to something a little bit wider, we might be able to get better grip on the salt and go faster, which is obviously our ultimate goal. We're also developing a new wire harness. Going back to what I said earlier, we wanted to document and trace the old wiring harness, but why document and trace it when you can make a new one that looks nicer, operates better? I was also told that there was suspected noise within the CAN lines. And so understanding where to send signals instead, can we beef that out? Can we change, the way everything is wired up? We can get, better data. We're on the back end after the race when we're analyzing everything and understanding our performance. We're also going to be testing to validate those changes. We're going to do performance cycling and thermal validation of the battery pack. We'll start, at the modular level, then build up to the whole pack and run a race simulation. This is important, one, to make sure it works. Battery pack takes a long time to design and manufacture, so we want to make sure this works before we go and race on the salt. We also want to make sure that it's safe. And so, as I'm sure you know, lithium ion cells, once they reach a certain temperature, they could become very dangerous. And so we want to make sure we're operating within the thermal limits of our components. Another thing we're going to do is test track. We're going to do that at TRC. Going back to the inefficiency of our system, actually running the bike with all the components together will be good. Because, you can test everything individually, but when you put things together, there may be unexpected issues that you don't know about. And so actually testing the bike at CLAR or at TRC will help us understand how it's going to perform when everything is together. And our ultimate team goal for the year, obviously, is to take a trip back out to the Bonneville Salt Flats and break land speed records again. I'm really excited for this team. I see a lot of great work that we're doing already. I really look forward to this next year. And I hope everybody looks forward to that too. Thank you.
Baja team is up next. Come on up. Sure.
Let's talk Baja. So, welcome to EAB. My name is Nasser Wada, and I am this year's Baja Buckeyes Drivetrain Director and Treasurer. So just a bit about us. We are a collegiate racing series where students design, build, and race single-seat off-roading vehicles across the country against teams from across the world. We are primarily made up of undergraduate engineering students, but we're not just limited to that. That's especially highlighted in our business and social media marketing team, where we have a business or a sports industry major as our social media marketing lead, as well as finance and accounting majors on our business team. We have 8 total sub-teams, that being brakes, business, DAC, drivetrain, chassis, suspension, steering, and social media and marketing. We're focused on automotive and motorsports industries and offer hands-on experience in engineering and fabrication, meaning that when we have a new class coming in, they're lined up learning how to weld, learning how to use CAD for the first time, learning how to run FEA, and ultimately build a driving car. We also build practical skills and industry knowledge through real-world projects that end up on a lot of our members' resumes, which helps them land internship opportunities and post-grad job opportunities. A quick season recap. We went to 2 competitions, 2 of the 3. First one was Baja, Arizona in early May, and then also Baja, Maryland in mid-June. At Baja, Arizona, we achieved 12th out of 69th overall, which is one of our best finishes in team history. And this is especially highlighted by the top 10 finish in endurance, which is for the first time in team history done. We believe this is due to a really good drivetrain design, as well as the new dual rate shocks, making it easier on the driver to endure a 4-hour Le Mans style race. At Baja, Maryland, we outdid ourselves and got 11th out of 98 with top 10 finishes in endurance and design and a top 5 finish in hill climb. We believe that we did so well in hill climb this year due to our new CVT calculator. Basically, it allows us to model how the car is going to perform in any environment with inputs like driver weight, car weight, incline, and tell us how to set up our CVT to best perform. Some goals for the upcoming year. First, we'd like to attend all 3 competitions. As I said before, we only went to 2. Next year, we believe it'd be a great opportunity for the team to attend all 3. We also like to place top 3 at one of said competitions. 3 years ago, we got 36th overall. 2 years ago, we got 25th. This year, 11th. We're shooting for the top 10 this year, and we're going to be competitive, reaching for a top 3 finish. To get there, we're going to have to do a lot better in our static events, and that's where the next point comes in, reaching design finals at all 3 competitions. Design is one of our weaker parts this year, in previous years, but getting top 10 finishes in last year is really promising, showing that we should be able to make finals at least one of these. project management wise, we'd like to get the car done ahead of schedule. In previous years, the car wouldn't be done before a week to a day before competition, which left no time for testing and tuning. This year, the car will be done a month before competition to ensure that we are best prepared to compete. Here are some design changes for this year. First, I'd like to stress how important it is for data collection. This year, we reached out to Michigan Scientific and they loaned us their wheel force transducer. This gave us real world data to validate load cases, as well as see torque at the axle, which was 135 foot-pounds. We're also doing an H-arm rear suspension. Over the summer, we designed and prototyped a component to go on our current car. And after some driver feedback, we're going to move forward with it. We also found that it helps us, or that we also found that we're able to control our toe through suspension travel, which will improve our maneuverability and suspension events. We're also going to be implementing an anti-roll bar. In previous years, we decided that it wasn't necessary, but after our top 30 finish in maneuverability last year, we believe now is the perfect time to pull out the anti-roll bar and get where we want to go. The final thing is a repackaged driver selectable four-wheel drive. Last year, we implemented driver selectable for the first time, making it so that the driver can switch from 4 to 2 on the go. This year, it'll be moved to the back, and this will improve driveline efficiencies. Instead of having to spin up the driver select or the drive shaft while we're in two-wheel drive, we'll be able to focus our energy towards the rear wheels and make sure that we're quicker off the line and achieve a higher top speed overall. I've included a QR code here to a link to our website if you wanted to come check us out. But with that, I think that's all. Any questions? Cool. Thank you, guys.
To wrap things up will be the EcoCar team. Brandon, come on up.
Good morning, everyone. My name is Brandon Burley. I'm the project manager of Ohio State Local Force EcoCar, and I'm also the propulsion controls and manager modeling leads at Ohio State. So a little bit about the team. The EcoCar EV Challenge is a 4-year advanced vehicle technical competition, challenging 13 different college universities to re-engineer a next generation battery electric vehicle. So all the teams got a 2023 Cadillac Lyriq as pictured above, which comes stock as a rear-wheel drive battery electric vehicle. And the team goes and replaces the powertrain. And this is to make a consumer-ready vehicle. So we're focused on both increasing the efficiency and also optimizing the performance of the powertrain. This competition is kind of new compared to some of the others you might have heard about. This one is integrating connected autonomous technologies as well, similar to the auto drive, but instead of being an SAE level 4, it's an SAE level 3. And we also do a lot to identify and address specific equity and electrification challenges through outreach and partnering with other organizations to kind of spread the word on electric vehicles. So about the history of the team, Ohio State has been involved in the AVTC Challenge Series for around 35 years now, and that has countless accolades attached to the Ohio State name. I think one of the current stat now is out of the last 17 competitions, we've placed top 3, and of those 17, we've placed first 13 or 14 of those times. So we go out there and we go win. So for that, like I mentioned, EcoCar follows the ebbs and flows of the industry. So before it was hybridization, moving vehicles from internal combustion engines over to hybrids. And now this competition cycle was the first fully electric vehicle. So EcoCar historically replaced the powertrain of these existing vehicles, which means we now take responsibility for both the hardware and the software of the vehicle. And as of this competition cycle, autonomous features have been implemented by the team. We control the adaptive cruise control system, lane keep assist, automatic intersection navigation, and the automatic parking by the end of the year. To recap our season, EcoCar is split into 5 major sections of scoring. That's starting with engineering documentation throughout the year, kind of noting our design decisions in the system design and integration, our controls, and our autonomous sensor fusion stuff. From there, we go and compete in vehicle events. That's both in Riverside, California at the California Air and Resource Board, where they have a dyno set for efficiency calculations. And then this year we went to Yuma, Arizona to do all of the performance evaluations such as acceleration, drivability, and autonomy. We also get scored on project management track and kind of executing that project, the social media around the project, and outreach to youth. So, moving on. To recap our season, we had a standout year, placing 100 points above second place. So we got first place overall, and we knocked it out of the park on the connected autonomous vehicle side with ACC evaluation and energy consumption being first place. Intersection challenge was first place. We got around 2,000 more miles of accumulation other than the other teams, putting us in first. We wrote a final technical report on drivetrain optimization of torque splitting, which placed first. And then we also took home second place General Motors Women in STEM Award and the second place Propulsion Controls and Modeling presentation. Some goals for this upcoming year. It is the final year of this 4-year design cycle, so now we're mainly focused on the finishing touches, drivability calibration, now adding cooperative to our ACC systems, so taking in information from other vehicles, taking information in from the environment, and including that in our algorithm. We are going to have a finished automatic parking by the end of the year, a now real-time drivetrain optimizer instead of an offline map, and focusing now on the fault diagnostics and mitigation strategy if we lose control of a certain aspect of the vehicle, making sure it's in safe operating conditions for the driver and preserving our vehicle. We also are focused on youth outreach this year with continued efforts with Drive Electric Columbus, the Girl Scouts, and now we have a Boys and Girls Club series where every month we go out and teach them to middle school and high school students. Some final goals to complete all vehicle events. Here are some of the ones mentioned. Some new ones for this year is we'll be developing a one-pedal drive map. So for some EVs now, you can control both the propulsion, brakes with the regen and the get up and go that EVs offer in one pedal. And then focusing on our CACC evaluation by taking in all that data. We'd also like to complete the sweep. So this will be our 4th first place in a row. We end competition as first place, and we'll be the 2nd team in ABTC history to win all 4 years since EcoCart 3 in the Camaro. Thank you.
And congrats on the continued success. So if you put the two current ABTCs together, so BWC and EcoCar, in the last 20 competitions that they've held, Ohio State has been in the top 3 in all 20 of those and won 15 of them. So they continue to dominate. It begins with the students. A little bit of credit maybe to their advisors. So lead advisors, Dr. Sean Midler-Muller on the EcoCar side and Dr. Matilda Darpino, there's BWC. Dr. Rizzoni does a little co-advising both of them, helping out the students, especially through the master's and PhD programs, but this continues to be a phenomenal program. This program starts at the Department of Energy and has been funded for many years there. Huge impact. General Motors for decades has sponsored the EcoCar program. Stellantis has come on board with BWC. It was absolutely on the federal chopping block, and we really thought would not exist anymore. We learned just this last week, they're up to over 32,000 students that have come through the ABTC programs at 111 of the top universities around the country, around North America. But we're very excited to hear that they were able to save that program. Kristen Wall and her team at A&L, along with the entire operating team, was able to move mountains and do some amazing things. They have decided to merge all the ABTC activities into one super program for next year that was just announced this week. The public RFP is out there. They're going to invite 20 schools to participate, and they were able to work to get GM and Stellantis to partner together on one competition. We're just learning there are 2 tracks, so 10 teams will be in the GM track, where they'll start with an electrified vehicle, and all of this is in the public RFP that's out there, but they'll start with an electrified vehicle and they'll bring a lot of autonomy into that program. Seems like it's going to be pretty autonomy focused with a tie back to powertrain. Sounds like maybe some of the concepts that we worked on in our next car program as a student competition. On the other side, Stellantis, the word off-road was used a lot of times in the RFP, so I think we're starting to get some hints. Seems to be more of a powertrain control implementation program, more like some of the previous eco cars, a little less autonomy in that program, but more focused on powertrain and optimization for an off-road vehicle. And then in the middle, the way they're going to choose an overall ultimate winner, there's a track winner, and then there's a center competition that's an innovation challenge. And they really want the teams to operate like a startup. And there's going to be a lot of sort of startup culture, innovation, and commercialization aspect that all 20 teams have to work on. And so there'll be a winner with each vehicle and then an overall champion when you merge the vehicle points with that innovation challenge. So seems like a super cool program. We were absolutely thrilled they were able to save the program and keep most of their workforce. They did have to, unfortunately, let a few people go from the team. Bringing the two programs together has a little bit of scales of efficiency. With that, we're already seeing, though, there's a pretty dramatic cut in some of the funding to the university that would flow through DOE. So we're just starting this week to put together our financial package to make sure. I'm looking over at Meg because that's what we work very hard on together. We will find a way to be in this competition or at least apply to it. We do have to be accepted, but we hope to be amongst one of the 20 teams to compete. In addition to the students and the faculty, all of you have helped out the program in some way. We will continue to look forward to your support, but I think almost everyone in the room has some components on that vehicle, and one of the reasons we've been able to continue to win and to dominate is the great relationships with all the companies in the room. So thank you for your support, and we're excited to apply for the next round.
Thank you, David, and thank you to all of the student teams, the representatives who spoke to you did a fantastic job, and you can tell their enthusiasm for these things. So over the next, give or take 45 minutes or so, we're going to talk about some of our research activities. And in the first, this first stretch, we're going to focus on topics related to battery electrochemistry, battery materials, and related. So the first presentation will be given by Professor Nariman Kim, who's going to talk about the new battery cell manufacturing facility and some of it. And when you're done, please introduce time.
Thank you everyone for coming down to CAR. I'm Associate Professor and BKK in Aerospace Engineering, as well as the Associate Fellow at Center for Automotive Research since my joining at OSU in 2016. Actually, today's talk supposed to be delivered by my colleague Jay Sayer about this battery R&D center because he is the leading figure for all the new battery facility. Unfortunately, he isn't traveling now, so I actually substituting him for the first part of the talk. The battery center, as the leading person name is Jay Sayer, who actually joined us 2016 from Bottel Memorial Center. He was the fuel cell director before, but converted to battery person together with me, and have been working us together closely for the last decade. So why we need that battery facility here? We have the great investment in US across the worldwide, and one of the good benefit and geometrical benefit of Columbus is first, we are close enough to the driving distance of the big three OEMs, including Ford and Chrysler and Stellantis and the GM. At the same time, we have the Honda manufacturing facility just 40-minute distance from here. Then we have a lot of the OEMs around the country, but you can see that if you drove the circle around the 500-mile map, standard in the Columbus, you can see that 75% of the plants, battery plants, North America is concentrated on. It's kind of coincidence, but I don't know if it's political, but we have a lot of the attention in the countrywide and nationwide about the battery manufacturing hub across the country. So that we try to find out this opportunity to grow up the transportation and the battery energy suppliers so that we have the kind of missions to cover that we want to demonstrate our pilot scale excellence in industry relevant projects and demonstrate value in the real world environment. Also, we try to innovate the battery management facility because many of the facilities you see is more at commercial level. They are manufacturing the cell. At the same time, we would like to prepare for the next agenda. What is the next battery cell technology may look like? Is it solid state battery cell, fast charging battery cell? We try to address those specific questions, not only the material level in the university lab, but also we want to realize the prototype and try to engage with the processing perspective. For example, solid-state battery still been out there in the decade. But the question is how we can bring into piece order together and how we can cheaply fabricate in the cell and safely. That is the next agenda for us. So we try to focus on this innovation. We would like to accelerate the R&D in the same perspective and learn together how we can get some more bigger footprint in this domain. So that we are very proud of saying that in techniques readiness level from 1 to 9, if you are familiar with that, we have the techniques 1 of the basic chemistry to 9, close to that system level testing and full understanding of the system for the commercialization. In our lab in nanotech, I will introduce momentarily. We have the energy innovation lab 5-minute distance to the west. We have the shared battery facility is open to public and also some of the company, but it's active hub for the material study in OSU. So we do material development and cell materials, and we synthesize the solid-state battery cell material as well. And we actually prototype cell, we call it coin cell testing at small scale. Then the new battery seller will serve as the home for the scale up. So before we actually make a large scaling up, we want to prove the concept that coin cell level, but more industry relevant scale, like the pouch cell, maybe 3 to 10 ampere hour pouch cell or cylindrical cell before we move into that next agenda. Then we have the Center for Atomic Research that is fully capable of actually testing all the cell level to the pack level to that modeling part. So with the control. So we have the kind of very wide range of the technology spanning from PLL1 to 9. This is very unusual for academic setting. So we are very proud to say that we are starting getting all these layers across this many investment from our valuable collaborators. One of the most successful events we are doing is that we try to utilize this facility not only for research and the demonstration, but also for educational goal and future workforce training purposes. So that is actually one of the meaningful events for us. We have the battery, it's not Y, it's I, reaching academic training through experiential innovation. This is funded by NS program. And the goal is that we demonstrate as testing bed how we can actually train the undergraduate students, transition to naturally engineers and workforce training through this summer program. So we actually have a 3 years grant. So it started from earlier this year. So at this summer was our first testing bed. We actually recruited 8 to 10 students cohort across the Ohio, including OSU, Perth, Columbus State University, and the Wilberforce universities. So we actually trained them for 10 weeks in summer school. And then the goal is train them as they make the train the basic knowledges and give them the hands-on experiences. And not only that, we have the industry project. So you are welcome to serve as our mentor for the future industry project. For example, maybe you can send the student to your facility, they can be trained and come back, and they try to sit down with you and try to solve the meaningful engineering solutions. That can be, then they will be your future employee, hopefully. So these are the faces of the 8 students who joined and successfully complete this program. So you can see that there are different nationality and also different geographies. So we can see that from different schools, we will recruit a diverse students group as a cohort, and we could actually go through that program successfully. We starting from training the battery one-on training in my lab. So we can train them what type of material we use and how to process it. Then they actually go to a larger scale. They actually supposed to be in the battery lab, but this is still under construction at that time. So they actually help us to build up this system of the facility and installation. Through the installation, they also get trained. And also they are helping us some immediate issue, how we can make the dry room communication more easily. So they have the video tape and they have the audio supported so that they can communicate both the outside the dry room in their facility, in the company in Michigan or Cleveland. They're communicating each other and manage the experiments virtually. And we also have the industry trip, in this case, Schaeffler graciously hosts them. So they have the 1 2-day field trip to Schaeffler and they see the real industry setting in R&D. So I think that is all wonderful and excellent learning curve for the students. and the program should be that workforce for future generations. So this center has been only possible by the generous contribution from our industry and government partners. And one of the most mentioned is that Honda is the lead foundation partner who committed $15 million in total. And then also we have the Schaeffler, Stellantis, Cotima, and Machinery Group as the foundation partner of this facility. And we also have the Jump Ohio who helped us to create this beautiful facility, as well as the Columbus region, and also government supported by the governors, Senators Sherrod Brown and the U.S. representatives to gain funding from the federal government support. So we actually got 35 million total to accommodate the dates. So we will, in this afternoon, after lunch, if your schedule allows, we'll be happy to tour the battery cell center dry room facility just 2 minutes down the street. So we're gonna guide you and tour the lab for details. But we have the 22,000 square feet total in the land space wise. And among them, the core facility dry room is 6,000 feet scale. So 6,000 feet scale, and among them, 4,000 square feet is dedicated to negative 40 degrees Celsius dew point. It's not temperature, but dryness. So negative 40 degrees Celsius dryness is kind of corresponding to little below the 100 ppm level of the moisture. So it's kind of ultra dry condition for better manufacturing. And close to 16,000 square feet is dedicated to negative 60 degrees Celsius dew point and higher. That is corresponding to less than 10 ppm of the moistures. That is dedicated for solid-state battery studies because we use the lithium metal or sulfide where the moisture is very sensitive. So we try to use that space for solid-state battery R&D, but the other area is mostly for lithium-ion battery facilities. So for now, we only consider the pouch cell at this beginning for phase one, but we do have a plan to scale up to accommodate some of the cylindrical cell based on your interest, like 18650 or 21700. So following that, we're gonna go brief introduction of the Energy Innovation Lab. This is just actually 5 minutes west from here. So nanotech west from your building. And I'm using the kind of 3 columns on this building up front. So this is more like a basic material researches, and it's the kind of collaborative model. When I joined OSU, Georgia and the senators requested me to make some shared facility for battery R&D. So this is facility open, and you can actually use it based on the contract, but we have to go through carefully. So this space is more likely material development. So because of timeline, we may not go through details. We're gonna just show you what kind of material study we are doing in the lab. So we are developing high energy and low cost cathode materials. So we actually do synthesize material design, like a core shell geometry or concentration gradient. So we actually do that, making up one particle with many different chemistry in it, just particle level. Then we also kind of ion substitution at the one. So we try to develop what is the low cost but environmentally friendly material for future vehicle. So we began to liquid cathode materials, but after this Ukraine war, the nickel price soaring up, then people are keeping us, hey, cobalt-free but low nickel. So we have to work on some of the manganese and iron-based chemistry now. So we are using a manganese or manganese including chemistry in the lab. So another project we do is that we do developing the silicon anode because we care about the fast charging. So recent activity, we used to do the pristine silicon anode, but we actually further tune it to affordable for intensive fast charging, so 6-minute fast charging. So you can see that the silicon material cannot support that at all. But if you just making a nano engineering with the graphene oxide and coating and chemical bonding, you can actually get 70% of capacity at after 60-minute charging. So we actually make a half cell and we go to full cell. Now we are currently doing a DoD project with the US Army to prove the concept. So we do a high power and low cost cathode materials. This is an R5 project led by Professor Enko in chemistry. I'm more like supporting her cathode. So we actually do see that NMR chemistry can still do the fast charging. This is kind of 2-year-old data. Now we already met the goal. So we actually going around 160 to 70 now. I'm proud to say that. And LFP lithium ion phosphate is there. It's a traditional fast charging chemistry. This can now improve around 130 mark. And LMR cathode is now currently 160 to 70 mark. So we actually make a great improvement on how we can utilize the conventional material for fast charging application. Of course, there are trade-offs. It may lose the energies, or you may also gain the power. So there are some good balancing might be required in the material level or say design level. So we also do the recycling, and we kind of came up with the idea how we can generate the lithium ion phosphate much cheaper way, just using an iron scrap metal. So we try to use the iron scrap metal to convert them to lithium ion phosphate and make a lithium ion olefin cathode in our lab. So one of the same activity I worked with Giorgio and the material in the back is that we work with another OEMs, and they send us the cell that is entire from the electric vehicle. So we actually take their cell. So we actually open it up, this 40 ampere hour cell, and with a different mileage on it, and we characterize it, and we actually investigated what is the source of the cell degradation. So then we can mapping it out in your cell design, how much capacity is coming from active material loss, how much capacity loss is coming from lithium loss, so that we found that our characterization is matching with their actual capacity. So it's more likely project how we can debugging those aged cell and find the root cause of degradation. That is a very for first modeling. The second, how we can design better cell in next case. We also do some other project, this interesting project for structural batteries, so that it's more likely you use a carbon fiber and epoxy as part of the cell component. And we don't, it's a non-traditional cell, and we do mechanical testing. So the idea is that you can just put in the roof of your vehicle or body of the vehicle, become the battery cell. So it's not really only for that transportation purposes, maybe it's for aviation as well. But we try to make a structural battery cell so that your body of the instrumentation can be part of the battery. So you actually kind of auxiliary power from there, or you even in the future, if you can get enough energies, you can completely remove the paradigm or form factor of the conventional battery cell. Also, we actually investigate finally this lithium and both sodium solid state battery cell. We actually starting from the basic characterization, in situ characterization, how this dendrite behavior is affecting the solid state battery cell. But we actually developed the testing protocol, how we can get replicable data about the sensitivity or stability of the battery cell by using a new testing method. But at the same time, we actually investigate how we can passivate the lithium metal so that we can actually improve the stability and safety and cycle life of solid state battery cell in the future. So this is actually our model. We actually would like to get some input from partner industry partner, what is needed in the near field, and we provide the engineering solutions. And sometimes we find a pattern together in the IP domain so that we have to have a winning strategies, which is very successful so far. And I appreciate your attention. And I think that we have a next target, Dr. Kang Soo, who is actually recently will be soon recruited by Ohio Administration. Okay. So he is actually the SES AI CPO, and I think he has a very of time to coming down to Columbus. And because his talk is about the AI-driven material discovery, so you're gonna get a lot of insight from his talk. Please welcome Dr. Kang Soo.
Good morning, ladies and gentlemen. Thank you very much for the introduction. Really my honor to be here. So my talk is sort of peculiar, a little different from the previous ones. My talk today will be confined to two separate topics. First one is the electrolyte materials that I have been researching in my last 35 years, and 27 of which was dedicated to Army Research Lab. And 2 years ago, I retired from the Army lab and joined the industry. So that's where I started the second part, that's AI for science or AI for batteries. So this is the rough outline I'm going to follow. I want to start I always want to start the topic with the history. And then my career number one, that's the electrolytes and interface, and career number two AI for batteries. So probably I'm looking forward to the career number 3 pretty soon. Okay, the beginning of electrolyte actually started in 1834 by this great person. I'm sure you all know his name, Michael Faraday. At that time, the first battery was already invented, voltaic pile invented by Alessandro Volta. So Faraday used this device, apply the voltage on the two water solutions made from the white powder on his dinner table. One is sugar, the other is salt. And difference he found is that one solution conducts electricity, the other does not. Therefore, he observed that meanwhile the one that conducts electricity starts to generate bubbles at both electrodes. So he realized that there's must be something going on. So the title of the thesis in 1834 is on electric decomposition. Something was decomposed. In this paper, he first for the first time wrote down this word in English vocabulary, electrolytes. It was derived from the Greek etymology. First part is electro, second part is glutos. Anyone speaks Greek here? No? Okay, good. I will give it. So the word of the coinage of this word is that there's something has to be taken apart by the electricity in order to be an electrolyte. So that's the reasoning he done in the paper. Something has to be decomposed. And interestingly, in this same paper, he created a series of new terms. First of all, at that time, he already knows that electricity and magnetism are associated together. So in order for the electricity to go through the two leads of the battery, there must be a road for electricity, that's electrodes. This word was invented back in 2. And number 2 is that since electricity has passes through the solution, it must be creating magnetism. So he imagines that just if magnetism was created exactly the same way as the Earth, then there are two separate, different directions of the ions or the charge-carrying particles to go. And how to determine the direction of the charged particles? Well, Trump knows that's right-hand tool, right? Magnetic and current. There's one charged-carrying particle that goes west from Greek word that's kata or cation or cathode. The other one is ana, Greek is where the sun rises, is cation or anode. All these words are still being used today, encompassed by first 30 years of the research, electrolytes, ions. And of course, those ions, anions, cations, collectively called ions, they must be produced by electricity. That's the proposal by Michael Faraday. He also mentions that the most important things happens at the surface of the electrode, so that's interface. Basically, that's everything I have been studying the past 30 years. But even great as Faraday, it was not always correct. I marked the error there in red because those ions do not necessarily be created by electricity. And this error was later corrected by Arrhenius, another Greek name. Long story short, at that time, 1884, he was studying for PhD in University of Uppsala University in Sweden for PhD. He was studying the qualitative properties of the solutions. That's the depression of the melting point, the vapor pressure, dP, blah, blah. He noticed that the salt has much stronger effect than sugar. So he connected two things together. He proposed this new concept of dissociation. The basic concept is that the ions do not need electricity to be produced. They are already there. You put the salt in the water takes the ions apart with those discrete ions which move independently. But his PhD advisor didn't like the idea. he almost didn't pass the PhD qualification exam. However, he was very stubborn, he was very energetic, he communicated actively with his peers at that time. Oswald, Van Hoff, those people agree with him, supported him. His paper got published. 150 pages of his thesis already, eventually got published. So eventually, he not only passed the PhD exam, got his PhD degree, he also got the Nobel Prize in 1903 for this work. Those are the beginning of the modern electrolyte science. Electrolyte science actually can be divided into 4 different parts. The ionics, how the ions are distributed across the field as divided into model. Then how the ions move, migration, diffusion. Then the interface, how the ions or the electrolytes interact with the electrode surface. That's what Faraday told us, where the most important things happen. And finally, the electronics class. That's what we are doing for the modern battery science interface. That's a entirely new animal. So 2 years ago, after the pandemic ends, I published this book, which was written during the entire pandemic, 2.5 years. I was trying to develop this new branch of the teaching for the electrolyte science, encompassing all these contents. And earlier this year, this book was translated to Chinese. It got, the sales number Chinese version was much higher than the English version, and we all understand why. We need to bring back the science to this country to do more new energy, the battery science from the bottom up, and make battery engineering, battery manufacturing again. So in my past 30 years, I have been studying a lot of time on the interface. My initial interest was initiated by this ECPC disparity. At that time, I was imagining that there must be something to do with the solvation structure of the ions, working ion, how the working ion interact with solvents, additives with counterpart anion. In early 2000, I was invited by Professor Whittingham to write this first review article of my publication list. 2004, it was published. In this paper, instead of just simply reviewing other people, what other people published before me, I did some my own thoughts. I for the first time proposed that ion solvation must be playing a key role in determining not only ion transport in the bulk, but also the interface and interfacial chemistry. So long story short, this is a picture I draw as a design philosophy for the electrolyte study. Imagine that a solvent ion in a perfect solvation sphere is brought to the surface of the anode. There are 2 possible scenarios. The charge transfer happens across this interface. If electrons pass to the central working ion, then you have electrode deposition. That's what happens with the working ions, which has high reduction potential, such as silver, such as copper, or probably with zinc. But zinc is very close to the decomposition of the water. Then there's another scenario. If the working ion has very low reduction potential, then the working ion never gets chance to be reduced. What happens is that the electrons pass to the solvent molecules in the solvent structure. What it got there is that the solvent decomposed as form of solid deposition on the surface. That's ACI or CEI, depending on which side of the electron it is. After formation of the ACI, if you are lucky enough, then scenario 2A, working ion goes through the ACI, you have electron deposition. That's what happens with the old beta batteries. Or if you have a interconnection host under this ACI, then what you have there is a lithium-ion battery or sodium-ion battery. So this idea has been accepted extensively by the community since then. There are lots of new electrolytes published since 2010 under different names: super concentration electrolytes, locally concentrated electrolytes, weakly coordinated electrolytes. They all evolve around this central idea of how you adjust the relationship between the working ion and the solvent molecules and the counter ion. Still a long way to go. There are lots of fundamental studies to be performed with. I don't want to go into details. One thing I want to mention is that one fundamental issue that has not been well addressed is how the working ions meander across the ACI, across the CEI. Because in bulk state, those chemicals do not conduct any ion. But somehow the batteries we're having today has very high power density. So if we can get this problem solved, then answers the basic question of the solid electrolytes as well. Because ACI, CEI, essentially they are electrolyte, solid electrolyte themselves. Now here's the second part of my work. But to begin that, I just want to give you a very brief summary of the history of how lithium-ion battery was invented. Whittingham demonstrated the first interconnected chemistry in 1972. It is ExxonMobil lab. Good enough to cover. Yoshino came and his group came in, replaced lithium metal electrode with a carbon-based interconnection anode. You have a pure interconnection electrode. Then Sony commercialized it. Until then, graphite was still not used. 1991, that's 1 year after Sony commercialization. The engineer at Sanyong, by accident just found that ECL graphite has a match chemistry. That's its basic fundamental configuration of lithium battery. That's what we're having today, cycling for thousands of times. CEI and ACI, both sides, make sure that we were speeding up the cell as well. From the 1972 to 1991, that's exactly 20 years. During those 20 years, computation chemistry did not help. There was no AI, no machine learning at the time. The entire process was very lengthy. Exhaustively studied, but basically purely on the empirical approach. And we want to change that for the next generation of the batteries. You might already know that the 2019 Nobel Prize of Chemistry was awarded to three, Whittingham, Goodenough, and Yoshino. For Whittingham himself, this process actually from the very beginning of the interconnected chemistry demonstration, the final Nobel Prize took almost 50 years, very long time. On the other hand, 2024 can be named the year of AI for science. The Nobel Prize for Physics and Chemistry were awarded to different techniques associated with AI. The neural network and the AlphaFold, which predicts the 3D configuration of the protein based only on the sequence of the amino acid. For the youngest recipient, the jumper, this process only took six years, very, very short. That is, it shows how dynamic, how exciting the AI represents. So what I have been doing since I joined the ACS AI, I was trying to leverage this new dynamic technique using old sorts of AI techniques. But to start with that, I built a very large database, organic database, heavy under 20. We exhaustively enumerate all the possible molecules that could exist in the universe. So the word universe here is not exaggeration. It's really encompasses all the possible combination of the molecules. On the basis of that, we did a huge amount of calculation. We built the gift database of 500 million already finished. And earlier this year, April 2025, we released this molecular universe as an online product. This is what you see here is a map of the molecular universe. As for neutron species, all the molecules, solvents, additives, dilutants, you can name it, they're all there. The only challenge is how to find the right one. Also, we built the inorganic and the anion database. Also, each of those are large numbers. So we did high throughput calculation and simulation on all levels from the single molecules in the vacuum to the condensed phase to the all the way to the interface. We build up different models. So this is what we do, how to help you to navigate in those huge database. We build our own large language model. I assembled a team of over 20 AI machine learning scientists at ASTS AI. We have our own large language model, which outperforms most of the mainstream large language models, including Grok 4, which was promoted so much, advertised so much by Elon Musk and the AGI, artificial general intelligence. We showed that those AGI models actually do not work well in the subdomain of chemistry. All these large language models work very well in mathematics and physics, but in chemistry they always score 40. For example, is that we extracted all the electrolyte chemicals used by people since the last 30 years. Let's say since the invention of the lithium battery, about 600 of those. We asked the large language model to name. We give the name of those chemicals to the large language model as we generate the right correct structure. And then you can see that this is marked by red. Those are the errors. And Grok, which is the most imaginative, most powerful large language model, hallucinates most frequently. Large language models are very good at creating creativity, but not very good at the scientific rigor. On the other hand, our own model, MU0.5, performs best. It only make one tiny mistake here, marked by the yellow one. That's tiny error, but the structure can still be generated. That's the final score of the large language models we tested back then a few months ago. We also found the AI tools, molecular universe help us to identify the new molecules which really work in the physical world. We actually successfully synthesized 3 or 4 of those molecules. So more are under the way. One successful example is for the lithium beta battery. We assembled the pouch cell here. You can see the AI molecules clearly outperform the human design molecules. And second example is the lithium battery. For the high silicon anode cell, we invented the entity which was recommended by AI after the AI model was trained by 70 million papers we collected. So, long story short, we have this molecular universe. I'm sorry, I should not do this. Okay. It's being right in the summer issue of the ESA's Interface magazine. It's highlighted on the cover. And later this month, October 20th, we're going to release the newest version. Can you skip those because we don't have that much time. Here, October 20th, we are going to release this newest version. We call that Molecular Universe 1.0. It's even more powerful. Has added the features of not only the more powerful as before, but also the features of the predict and formulate, which can directly link the both single molecular property to the cell level life prediction and the battery physics chemical properties of the electrolyte solutions. And it's really a new horizon. What I just talked about is AI for material design. At the same time, we know that AI has extensive use in very different areas of the battery manufacturing, safety, the life prediction, and as well as the characterization. So with this, I want to wrap up my talk and I want to thank you for your attention. I'm looking forward to the exciting collaborations here with Jojo, with Jay, and with Yong. Thank you.
I think Kang was so kind to be very efficient with his time. We do have a few minutes for questions. This is a fascinating topic. Anyone who might want to ask for a clarification question? And of course, Tang will be with us. Yeah, please.
Dr. Kang, thanks for the nice presentation. I was amazed how this AI is growing virtual development aspect. So just for general questions, what is the subscription model and how much it may be cost of that's your brilliant TensorFlow database?
Okay. That's an excellent question. It's very costly to build up those gigantic database. Even just to store them is costing a fortune. Since I joined the company until now, if we don't count the expense for building the team or the manpower, the database itself has costing us if I remember correctly, more than $10 million. So good part is that this is getting a reiteration in many runs of iteration becomes more and more powerful, and this is really a dynamic field. There are a lot of tools that which are not even available a year ago. We are adopting, and we're getting clients as well. So far in the AI world, that there's no a certain model of making monetize AI. It's still difficult, a challenge. But we managed to really attract the big corporations to sign up. And it's really just the beginning. In the future, I foresee that this tool will be more and more extensively used. I often think that when I use the tool by myself, I often think that when I was doing PhD, I really focused on this tool that could save me months and months of paper chemistry. Yeah. Thank you.
Thank you very much. Let's thank Dr. Shu again.
Thank you.
And continue chatting about some other current activities and project updates. And the next topic, I'll get it started, but I would like to invite Dr. Eke Mursader to join me in here. We've been involved in some activities that are related to intelligent road safety systems research. And I'll start with the brief introduction, and then I'll let Ekim explain to you some of the technical details of the things we're doing. But we responded to a challenge posed by the U.S. Department of Transportation through a program called the Intersection Safety Challenge that recognizes that a significant portion of accidents occur at intersections, and a significant fraction of the casualties that result from accidents actually occurs at intersections. And so we wrote a white paper and applied for an award under this challenge. And in doing so, we leveraged capabilities that we have in collaboration with our great partners at the Transportation Research Center. And I will let you tell the rest of the story.
Thanks, Giorgio. Giorgio made an excellent introduction. So in the previous EABs, we gave you updates about the Intersection Safety Challenge. We were among the winners of phase 1A and phase 1B. Phase 1A focused more on the concept of our system, which is designed to improve safety of all road users, right? The idea is we have a smart intersection. We use multi-sensor data, including LiDARs and cameras, and then we do object prediction, movement prediction, and scenario evaluation to understand whether any collision event is likely. And depending on the scenario, for example, if two pedestrians are on a collision path, that might not be of high severity, right? We will just bump shoulders and we'll be on our ways. But if a giant semi-truck, is coming in and there's let's say baby on a collision pattern, that is a high severity. And so that key scenario evaluation is actually where our IP lies in, and we filed a patent application for that. After we do that, we decide whether to take action. For example, we can turn off the traffic signal to red, stop the traffic. But if it's like maybe a lower severity event, we might think this is sending an alarm. So long story short, we won 1A with that concept. And then during 1B, the DOT shared a data collected at their pilot intersection at Fairbanks Research Center in DC. And the idea is, okay, now we have the concept, go implement it. However, validate your implementation with the data that we sent. And they use dummies. And actually, we had collisions. And then the idea is, you have the raw sensor data. Can you predict this event before happening? And we were amongst the winners of that phase as well. And you see that's our system in work. Okay, so what's next? There's 1A, 1B, and we have some intellectual property with the help of Ryan Zinn from the commercialization of this at OSU filed. What is the next step? Well, the next step is we validated the system with, if you would, it is real data, but it's coming from a toy intersection, right? It's not naturalistic. It is in a controlled environment, right? Like DOT literally pull a dummy, and then a driver which has the intention of hitting the pedestrian, hit the pedestrian. Now the next step is, can we deploy this technology that we developed in a real intersection and see if we can really detect the collisions with a impactful or with a prediction horizon that will be useful to warn people for all participants, right? And we made the proposal, and then we won like an OSU award called Accelerator Award. And we started this project 15 days ago. And I really would like to thank Mark and Nick. Mark is from City of Dublin, Mark Bill-Saber, and Nick Hagemeyer is from Odo. With their supervision, they advised us to use this intersection, not that one. As you can see, that's the Dublin link. The idea is there's a high amount of pedestrian flow there, which will cause a lot of vehicle and pedestrian interactions near that intersection. And City of Dublin has already smart grid infrastructure there with a vendor. And the idea is we are going to use our algorithm with the metadata and the raw data coming from those sensors and see if we can predict these events before happening, and that will validate them. This is a 1-year project. The idea is we will refine our software, deploy our prototype, and then validate. When we say deploy, we are not going to take action yet, right? There's no intrusive element. It's all about collect the data, run all your experiments, make sure everything works in real time, make sure that you are very accurate, and then conclude the project. Our team mainly from OSU CAR, but we have 3 excellent advisors that kindly provide us with little support, and across various meetings, we heard the pain points and guided the project slightly. And I just like to help everybody who gives feedback to us, because this is the whole point, right? Like, we want to make sure our research is hitting a pain point in this field, and that is all at this point.
Yeah.
Yeah.
Well done, thank you. And we're especially grateful to Drive Ohio and the City of Dublin for giving us the opportunity to do a deployment and an initial validation of these technologies. It turns out that we've come across multiple opportunities to submit research proposals to continue to pursue road safety in many different dimensions. One of the recent ones had to do with the subject of road workers safety. For example, could we deploy some of the same intersection safety ideas to protect road workers in potentially very risky situations? Now, you've heard us talk about the ARPA-E NextCar program over the years, and maybe this time it really will be the last presentation of NextCar. Dennis Kibalama, who has effectively served as the chief engineer in the final stages of this program, is going to give an overview of how the field day went and what the conclusion of this project is and what prospects we have.
I hopefully, maybe my dissertation will be the last. So there's still some additional, presentations to come out of this.
It's mighty close. It's mighty close.
For many of you who have heard about this program, it is birthed out of the US Department of Energy Advanced Research Project Agency for Energy. And this has been running since 2016, 2017. It's been split through two phases, where phase one, and the overall umbrella here is leveraging connectivity and automation to improve energy efficiency of vehicle. And it was going just not for passenger vehicles, but thinking about fleets, thinking about how to improve the overall energy efficiency of fleet and personal vehicles, heavy duty vehicles of the like. In our particular case, we decided to focus mainly on the passenger vehicle, and we've done some studies that show that these benefits tends to proliferate through to downstream traffic that's following you within a defined distance. But phase one basically looked at targeting a 20% energy efficiency over a representative baseline using up to the SAE level 2 automation. And in this particular case, we used the mild hybrid configuration. It was a 2016 Passat. And we were able to showcase in simulation and in the vehicle 16 to 25% energy savings over a representative baseline. And there's been a lot that's gone into this from over the years, a lot of different visiting scholars, different students, different researchers, different PIs. And there's a lot of different technologies that are showcased by other teams ranging from eco routing and a lot of, for example, the Google Maps that you have, the efficient routing, that is basically a child of one of the different Nexstar teams. So the goal of this technology was to get it to a point where in industry, it can be shown, bridge the gap between the research aspects of such a technology and getting it to be somewhat mainstream or get to a point where it can be applied and be shown to be real time. In phase two, we basically asked ourselves the question, could we extend this further to about a 30% energy efficiency benefit? And in this particular case, we're leveraging higher automation. And this was using a Chrysler Pacifica PHEV that has been equipped with an automated driving stack that's based off of the AutoWare AI stack, but has been customized and added with different flavors to be able to deploy our own vanilla flavor of our own flavor of Nexstar technologies that we've developed over the course of the project. Again, I mentioned we started with phase one, so a lot of the developments have been incremental. And in phase one, we had a 2-stage implementation, but we were not including time explicitly in our formulation. So dealing with time barring constraints like traffic lights, like other vehicles around us was somewhat of a challenge, and we had to include this through some form of heuristics. In phase two, we opted to include all of this information into our optimal control problem formulation. And basically, we improved that eco driving with eco approach and departure that was initially done in phase one, and then added another technology, which was eco adaptive cruise control. So accounting for the behavior that we're getting from different vehicles around us. And started off with large scale Monte Carlo studies from routes collected from Columbus area to be able to generate statistically relevant results. But a lot of this is really targeted towards, is it implementable in the vehicle? What are the benefits that we're getting from simulation versus what do we see in vehicle test results? So a lot of effort and time have been devoted to be able to replicate this technology, to be able to make it real time, be able to deploy it in a vehicle over the different courses of the project, to phase one and phase two, and done primarily on test track at TRC. With, again, I think Wadi mentioned to all the different partners of the project that we've had over the course of the years, TRC, Borgwana, through the different variations of Delphi, Delphi Technologies, and a lot of other partners that have helped us throughout this entire project. A lot of this would not have been possible without them. But this table basically shows a different range of the benefits that we've been able to see. And in this particular case, just in summary, you could get a lot of benefits, even ranging up to, 30 plus, 40+%, 50% benefits. But it's really dependent on what driving conditions, your initial state of charge. So it's not a one number that can define a lot of these benefits, but the benefits range from a lot of different variability that comes along the route. The key benefit from this is you still get these benefits even with minimal penalty in travel time. So in your particular case, you'll be looking at, not sacrificing the time or the travel time, or if you assign a dollar value to your travel time, deploying these technologies would still not cost you that. And this slide pretty much summarizes a lot of the different integration that has been done from, pinning different APIs, from the different developments that have been done by a lot of contributions from different students and, researchers and people on the team to be able to include sensing information, to be able to include control and actuation information, to be able to integrate these controllers in real time. What is worth mentioning is these technologies really have been developed in a flavor that ranges from not only level 0 to level 5. So it's basically dependent on what access do you have to the powertrain, what access do you have to the vehicle's controllers to be able to deploy whatever flavor of the technology you might be able to get access to. And that scales accordingly with the benefits that we have seen from all our different studies and different test cases. The project culminated in field data was done at the Advanced Center for Mobility. And basically what we're doing here is in real time, we had a mixed virtual and real environment that was mapped across the ACM highway, which involved different traffic lights, interacting with different vehicles, and receiving signal phase and timing information, basic safety messages, and in real time making adjustments to both the vehicle's operation and the vehicle's velocity, and in full automation around the track. And also consequently operating the powertrain in different domains to be able to, showcase the technologies. And key outcomes from this work, I don't think even this begins to list a lot of what has been done, but a lot of intellectual property has been produced from this, and in collaboration with Bob Warner. Publications, there's a lot of publications and presentations that have been done. I don't think I have the number, but Professor Rizzoni has probably done a multitude of next car related presentations in different places across 50, probably 50, and will continue counting. And really the value proposition here is this has been demonstrated in different vehicles, not just one vehicle, but the different vehicles over the different phases of the projects to showcase real world energy savings. There's definitely to the consumer through the OEM, there's looking at improved total cost of ownership that is benefited from the technology that has been developed over the course of the project. If you were to integrate this as a driver advisory, this is something you could think about as having added value to the OEM's infotainment system and what they will provide in that suite of technologies. And as I mentioned earlier, it's really scalable to deploy on different levels of automation, depending on what access, what hardware you have on the vehicle. And that scales accordingly with the benefits that we get from the technologies. Furthermore, we're kept going on in trying to understand how scalable are these technologies to leverage multi-threaded CPU architectures that are pretty much state of the art nowadays. And, additionally getting much more computational tractability, upward to 47% from a lot of studies that have been done. We've also taken further steps to deploy these technologies on smaller, compute platforms like think of like a Raspberry Pi running a dynamic programming based solution online. At the beginning of the project, you probably mentioned that that would seem somewhat crazy, but the ability to be able to do that and having potential partnerships with OEMs or other people who could probably bring the cost of ownership down due to economies of scale to be able to deploy some of these technologies. That would be a really good way to keep the next car technologies going forward. And then we're always looking towards further research, collaboration, and efforts. And one of the key things from this is really the vehicle platforms that we've brought in from this, and we're continuously developing and upgrading and upfitting them to be able to match the future research demands for ADAS, automated driving, and cab-related research efforts. Yep. So that's my updates. Thank you.
So Dennis, thank you very kindly, and he's a step away, probably a few revisions away from completing a PhD dissertation, and defense date is set, so that'll truly be the culmination of the next car project when Dennis gets, what is it, the third PhD that came out of this project? Fourth, sorry. Fourth PhD. So this was an amazing opportunity. We have Zach ready.
Yes, Zach is stepping on an airplane, so he's logging in remotely with us, but he's about to take over here.
So the next, somehow we're making it work.
All right, Zach, you can take over screen share if you're ready to go there.
Yes, so I'm not quietly stepping on the plane. I'm actually headed to the airport immediately after this. So can you see my slide?
It's working.
I think it's loading. Don't see it yet. Gotta.
Shows it's shared.
There we go.
Yes.
Just came through.
Okay, all right. Well, I wish I was there in person, but I'll be flying to California in a little bit for a conference there, which actually is related to what I'll be talking about here. So you'll get a little bit of a sneak peek of some of the results I'll be showing at the conference by LAX. So why are we interested in GPS alternatives for enhanced security of the national airspace? So first and foremost, thanks for CAR for inviting me to present to you, and thanks for their support and making what I will announce in this presentation happen. And also thanks for their support and several of the initiatives that we've been doing over the years to showcase that we actually have a solution for this problem that is really taking the world by storm. First and foremost, I thank my students, current and past, that you see here for helping out with pretty much everything that you are about to see. But if you are not aware about the issues of radio frequency interference, jamming, spoofing, and otherwise, and cybersecurity issues, cyber attacks that have been happening on GPS, this is a problem that is well known in the academic circles and in the military circles. But people, I would say civilians, didn't take it very seriously up until recently due to the several conflicts around the world and unrest that is really hitting civilian systems, which should be a concern for all of us. This is a date that will go down in the history books. September 2023 was the first time that GPS spoofing impacted commercial aircraft. And you can see here the script of what the pilot was saying. His plane was showing itself to be more than 100 miles away from, or more than 100 kilometers away from where the plane really was. So spoofing is a technique where you transmit fake GPS signals and you let the receiver, the GPS receiver, think it is somewhere else, right? So it's obviously catastrophic and safety critical applications such as aviation. And this is basically just a snippet
Zach,
of,
the slides are not advancing. We're still on the title slide.
Oh, wow. Okay. Sorry.
Now it did, jamming and spoofing. Yeah.
So there is a big delay, I think.
Yeah.
What can you?
You can, Zach, if you want to turn off your video, that might help.
Okay. Yeah, that is a significant delay. Or an attack on my internet. Cyber attack. Well, let me stop sharing and reshare again. Maybe that fixes it. Let's see here. How about now?
It looks like it's trying to share. We don't see anything quite yet. I'll let you know when.
Yeah, I'm connected Wi-Fi at home, so I waited not to leave to the airport so I don't have these issues.
It's still not showing. There we go. We see
Okay.
the jamming and spoofing threats to aviation 24-25.
Yeah, so let's see, because I do have videos and those would be problematic if they don't display properly. Okay. Anyway, so this is just worldwide news last year and this year, talking about how it is really impacting civilian systems, aviation in particular, from the Black Sea to the Baltic to the Mediterranean Sea to the Atlantic to the Persian Gulf, even in the US, right? It did impact aviation in the US, and it did cause Denver International Airport and Dallas Fort Worth International Airport to shut down certain runways for many hours. So this is so I can see that it's not advancing as I advance, but I'll start talking and hopefully it will show up shortly. What I'm showing on my screen, and you will see in a second, is a slide I got from the Department of Transportation that shows radio frequency interference impacting GNSS, or Global Navigation Satellite System. GPS is one particular case worldwide. Yeah, it's not advancing, is it?
No, we don't see it. There it is.
Yeah, there is a significant delay. So, okay. I don't know how to fix this, but I'll keep going. So yeah, so what you were seeing on your slide is just incidence worldwide. It spread like cancer, and you can see it concentrated in conflict zones, but also it is, in places where there aren't necessarily conflicts, where this is really affecting civilian systems. As I said, aviation is one example, or one particular system where we don't want it to be impacted by this, but you can think of your self-driving car when it's lost, it doesn't know what it is, or someone convinces it it's on this lane of the highway versus that lane, or not even on the highway altogether. So it didn't take too long for this to cause catastrophes, right? So if you remember the Azerbaijani airline that got shut down by the Russians back in last December, it was actually traced to GPS spoofing. So the plane entered the wrong airspace because it didn't know where it is, and then the Russians took it down. And last summer, there were two big oil tankers in the Strait of Hormuz in the Persian Gulf colliding into each other. You probably remember there was a conflict between Iran and Israel at the time, and GPS spoofing was just happening, all over that region. And last month, it started hitting public officials. So I think that's when, people will take it very seriously. So the head of the EU, her plane was spoofed when she was flying over Bulgaria. So I happened to be in Europe at the time, and there were lots of discussions that, this is now not a joke. We really, really need to find alternatives. So for those of you that are fans of the X-Files, the slide that you will see in a second will probably ring a bell. So basically, the systems that we are building, are inspired by The Truth Is Out There. There is significant delay. Sorry, I'm seeing the slides you are seeing, but you are way behind. I'll have to, yeah. Okay. So what solutions we've been developing in my lab and through the Carmen UTC, the University Transportation Center that we have here in Ohio State. So basically, we look at signals in the environment. We call them signals of opportunity. We look at different terrestrial signals, whether they're AM, FM, Wi-Fi, digital television, cellular, and so forth. Or these signals could be coming from space, right? Starlink is one example of low Earth orbit satellites that we can use, Iridium, Orbcomm, OneWeb, and so on. So I'm playing now. Yeah. I think you're way behind my slides. Can you see a video playing at all?
No,
Yeah, I mean, it's.
is this the video? It says drone setup?
Yeah. So is it playing or is it choppy?
It's not playing.
It's frozen.
Oh, yeah,
It's now
just
choppy.
moving slowly, yeah.
it's choppy.
Okay. Yeah, so basically the slide that I'm showing is some past experiments we had done to prove the concept that we are developing, that you can navigate a drone nearly to GPS level accuracy by listening to cellular LTE signals. So this is back in the days when I was in California, and we demonstrated that this is feasible. Then we took this to aircraft. So we jumped on some US Air Force aircraft, and then we demonstrated that this is also doable on their aircraft. So the video that you are about to see shows you, demonstration of this on an Air Force aircraft in the Mojave Desert, as well as over the Inland Empire, Riverside County in California, and different locations in Southern California, showing that, well, if you lose GPS, can you listen to cellular infrastructure down there and use it to navigate the aircraft and basically know where you are? So that flight campaign really delivered more than what we were expecting. It surprised us that there are so many good signals that you can use, and it's not gloom or doom. If you do lose GPS, there are things that you can do without having to build a completely new system similar to GPS, which costs billions of dollars to operate annually. So can you update me what you are seeing?
We see the airplane with now we
Okay.
see
Okay,
the
good,
start
good.
of the video. Yep.
Good. Yeah, so basically this is just a demonstration of this older work, as I said, proving the concept and showing that you can navigate with these signals. No, disconnected.
We are trying to upgrade our computer over here.
Okay.
So I think we might have more success.
Oh,
there we go.
That's video.
Okay.
We see it.
Yeah. I think it's now in real time, so I'm excited. All right, so you can see that. Look how accurate we can get to navigate the plane by listening to cellular towers underneath you. Now, this happened the week just before the world shut down due to COVID. I still remember we were supposed to fly for 2 weeks. We flew the first week, and then all the pilots were asked to fly back to their base, and then the world shut down. So those are not new results, but this is what you can do back with LTE. Not even 5G was not completely rolled out, especially in those rural areas that you see here, right? And the FAA didn't allow us in the first week to fly over 23,000 feet above ground level because we were getting close to a lot of air traffic in LAX and in Ontario's airport. So it always bothered us that can we fly higher with those signals, and can we use 5G, right? Because now we live in the fifth generation era of cellular infrastructure. And while that is happening, LEO constellations took off, and now they call them mega constellations. So you're probably aware of Starlink, but there are others. OneWeb, Amazon, Kuiper is also planning a mega constellation. Starlink, as of this month, they have more than 8,000 satellites in orbit, and they're projecting 12,000, and they're asking permission for up to 30,000. And China is building 2 mega constellations similar to Starlink, 15,000 and about 12,000, and Europe is building a mega constellation. So it is, a new space race, if you will. So the question is, can we do this? And for LEO satellites, you have two different schools of thought. So they are not only launched for internet connectivity and for cell phone coverage and so forth, they are also launched as PNT sources, or position navigation and timing sources. So you have, few constellations that are commercial that will say we will solve the GPS problem by having satellites that are dedicated for navigation. Then you have other satellites, right, that are saying, well, we are transmitting a communication signal. We are going to dual purpose our satellite to also serve as a GPS-like satellite. The approach we are taking is more sustainable from a spectrum point of view and from an infrastructure point of view, and even from a cost point of view. What we are saying is, well, why do we need to do this? Why don't we be opportunistic about any signal coming from space, and we can use it to navigate, right? Similar to what we did with LTE. LTE and 5G are not intended for navigation, but we used them, we exploited them for navigation. So this is not an easy problem, and I think this is what makes it intellectually interesting, at least to me, is that there are three segments in this layer of navigation. The first one is the space segment. This is something we will not worry about. We will let the providers launch their constellations. We will develop a user segment. So those are the receivers that you could put on a plane, on a car, or in your handheld device. And we will build the ground segment that will monitor these satellites and send correction data to the users. Of course, in GPS, as an example, the Air Force takes care of the space segment and the ground segment. And then receiver manufacturers take care of the user segment. But in our case, we have to take care of both the ground segment and the user segment. So we successfully built a ground segment here in Ohio State and the electroscience lab down the street from CAR. And we also built a user segment. So we built receivers that are able to listen to Starlink satellites and other satellites. But I think because Starlink has the most satellites, they are, I would say, the most exciting from a navigation point of view, because you could get really, really good accuracy if you know how to exploit their signals. So you can see here, we call it the Aspen ground segment. That's my lab that's based in the ESL. And then we flew this drone in Turtle Park last summer. And thanks for CAR, for David and Mag and their team to help us really to get this going. So you see here the drone and very, very low cost hardware, right? So now, if you remember a few years ago, I showed our drone, which is similar to this one, crashing in California because we lost GPS on the drone. So now, hopefully we don't have this experience again, because if you lose GPS, you can listen to Starlink and you can use it to navigate. So look at how accurate, this is in green, our estimate is to the ground truth flight trajectory of the drone. So this is us listening to Starlink, exploiting their signal, getting correction data from Ohio State's campus, and navigating to nearly GPS-like accuracy. Okay, so that's that. And this is exciting because last year we got congressional earmarked community project that was funded through NASA, about $1 million, to develop and demonstrate GPS alternatives for enhanced security of the national airspace. So the idea is we are in the process of purchasing an aircraft, park it in Ohio State's airport, and start demonstrating what you saw with the Air Force flight campaign and the UAV on a real aircraft, right? And then it's up to basically we have pretty much control over it, so we can fly whenever we want, and hopefully we can go to different regions and so on. So while we are waiting for this, we felt, well, I tell my students, if you want to start going to the gym and you don't have membership yet, just don't sit on the couch, maybe start by doing push-ups and prepare yourself. So to prepare ourselves for the aircraft to come, we felt, okay, what can we do? So if we do a stationary campaign, we just listen to signals and localize a stationary receiver. Well, that's not exciting. And that's something we had done, not too long ago. If we put it on a ground vehicle, well, the maneuvers of the ground vehicle are not also similar to an aircraft. And also this is something we had done last year, right? So that's not exciting. UAV, I just showed you UAV results. So what do we do? Urban air mobility? Well, also we don't have access to those. They're going to come online hopefully in the next few years. should we go to Mount Everest? And that's a high altitude, right? But, I'm afraid of heights and I don't want to go to Mount Everest. Should we jump on a commercial plane and do our test? Well, I don't want to get in trouble with the FAA, right? You can't just go willy-nilly and do these tests on commercial planes. Should I talk to my friends and DOD and try to get on the Blackbird? Well, that's an option, but I don't think we can do that very quickly. So we started running out of, I would say, physical phenomenon, and we came across this story of Icarus. So this is from Greek mythology, and Icarus was trying to escape from the island of Crete. And his dad told him, don't fly too high, close to the sun, because your wings will melt and you will burn and fall to your death. So that didn't deter us. We called our mission Icarus. We worked with our friends in Sandia National Lab to fly a weather balloon to more than 25 kilometers above ground. And I will show you, I will close with the video showing that we had done. As I said, this is in preparation for when we get the plane, we know what to do. We know what payloads to build. Of course, they will be slightly different because we will have more payload capability on the plane. Okay, so it was an effort that took a year. We had a bunch of undergraduate students that used that as their capstone project simply to build the payload. We wanted to fly it for nearly half a day. This is Brutus, of course, blessing our payload before takeoff. Nearly half a day to more than 80,000 feet above ground. So you see here, the balloon getting filled with air. We did the OHIO. There were only 3 Buckeyes on the team, so we used the balloon to be the last O, of course. And then they shut down a small regional airport for us in New Mexico. So we were doing, push-ups on the runway also for good luck. But of course, just wishing for good luck doesn't mean everything will work, and the experiment failed. So unfortunately, we will have to wait for the plane. No, I'm just kidding. We actually managed to get the balloon, the payload back in shape. Thankfully, it didn't completely get destroyed. And then about a month later, we got, if you can see here, another team of professionals, but this time we managed to launch the balloon. We collected signals from LEO satellites and from 5G. It traveled 65 miles, and it's an uncontrolled, basically just going with the wind. Then recovering the balloon was a whole different story, going through ranches, government land, fighting with Bevo here from UT, not knowing that he will come to Ohio State and he will get his back whipped. We recovered both payloads, the 5G payload and the LEO payload. So this is the LEO payload, right? This is using Starlink and OneWeb. And this is, if you notice there, it's 22 degrees per second was the yaw rate when we got to all the way, 80,000 feet. So it's pretty, I would say, disturbed environment that, of course, the aircraft will not experience something as crazy. But if we can show it on a balloon, I'm very hopeful that we can also show it on the plane. Look here, if you lose GPS, this is your unaided altimeter and rad, you really would be lost. You wouldn't know where you are. And that's the scary part, right? You are lost. Whereas what we are able to show is the green, very, very close to the ground truth trajectory. So that's with LEO. Let's go to 5G. Also 5G, we use different towers along our trajectory, and some of the towers were, tens of miles away from us, and the same thing. And it is fascinating because 5G towers are not supposed to service aerial platforms. Their antennas are tilted down and they are supposed to serve ground users. But we have very high sensitivity receivers that was able to listen to these towers and navigate the balloon all the way at these crazy altitudes. So with that, I thank you again, and I apologize for the little hiccup that we had. I thank the Office of Naval Research, Air Force Office of Scientific Research, Department of Transportation, NSF, NASA, Aerospace Corporation, and Sandia National Labs for funding this work. And happy to stick around for a couple minutes, take any questions before I jump on a plane, and hopefully spoofing will not happen on that plane.
Any quick questions for Zach? I think we're good, Zach. Safe travels to you. And thank you for making time for us.
Hopefully next time I will see you and I will show you our new airline. Okay,
Thank
take
you.
care.
Thank you.
Bye-bye.
With that, it brings us to maybe the best part of the day, the lunch hour, one of my favorites anyway. The lunch is just outside in the hallway. Tables are there. You can fill your plates, and then we have some tables inside of this room. If you come back in, and we'll eat here. And we resume at 1:45, I believe.
Yes.
Yes, so we'll see you in a little over an hour back in the seats.
If I could get some people back to your seats. I think we're ready to start again. Someone set an example as who Luca. Identify people. Luca. Come back, guys, you're back to me. Help me get people on. I hope you're enjoying it.
Oh, yeah, this has been, it's been great.
This one's we've been looking. Yeah, it's not a great day. We take full credit. Yeah.
Got a screen share. All right. And I just roll down your update.
Yeah. Yeah, everything looks good.
There we go.
It's up to you. Yes,
All right. Maybe. This computer hates me. Oh, well.
All right, welcome back. Hopefully everybody had a good lunch and got to meet some new folks. We've got two sections here in the afternoon. We're going to talk briefly about our construction update, why we're over here at Honda's 99P instead of at our facility. And then we'll close out with some discussion on our membership program and the next generation of membership. So most of you, I think the vast majority of the crowd has been with us for at least the last few meetings. So you're probably familiar with the words low now. So if, for the couple that are new, we have a very large program with the Federal Transit Administration out of USDOT for the next generation of transit bus technologies. This has been a 7-year ongoing program that we've developed and worked a lot with Congress to come up with how to use the money, what we could apply it to, and how to structure the program. And like all things in life, as soon as we finally got it figured out after a lot of pain, the government entirely changed, and everything's changing. So the great news is we got our construction underway just days before it needed to be in place, and that was not affected by any of the government changes or shutdowns. So construction is ongoing. There is a significant amount of money in the program that is currently locked up that we're not able to use in the way that we thought it would. We're working with our congressional representatives to kind of redirect that. We have very strong hopes that could actually, in the end up better for us if we can get a few things across the line. We'll actually be able to redefine the money and use it in a way that we think makes a lot of sense to advance technology. So one of those uses might be amount of the remaining money into equipment that would allow us to even better outfit the labs, and then to launch some new R&D programs that we think could be really impactful and in line with some of the goals of this administration. So more to come on that side, but for today, I'm going to talk a little bit about the construction. So just down the street at Card. Yeah, there we go. So this is our back parking lot of the Student Projects building that's existing on the right. And as a reminder, seen this before, this is the new building that's underway in the back. This is entirely lab space, no people space in this building. A large chunk of that is for battery laboratories. And so we're going to move all of our battery testing into that facility. Big focus of this program has been to develop a safe space that can handle very large format batteries. We can do up to a megawatt hour pack. The room is certified to have a large quantity of lithium in it. And we're going to move our cell, module, and pack cycling into that new facility. And we're also in the final stages of locking in some of our government funding to be able to put in a walk-in thermal chamber, so to be able to do large packs just behind that facility. So that's underway right now. There's also a large hydrogen fuel cell lab. Off the bat, we could do up to 250 kilowatts, eventually up to 500 kilowatts of load testing on bus and truck sized hydrogen fuel cells and systems. And that lab will also house our smaller stack. So right now we have a 1 kilowatt demonstration stack for teaching and learning and research. And we're envisioning something in the middle there. So a smaller stack for research until we go up into the full vehicle systems. And we also added on a large high bay space. So a flex space, completely thermally controlled, that will allow us to have even more space to continue to work on vehicles of all shapes and sizes in that facility. And for an overhead view, so the large building to the right is the existing car building, the student building, and then the new expansion there is in the back. So to walk you through some of what we've seen since they broke ground in June. So this was our parking lot just prior to construction. So we emptied the parking lot out completely for probably the first time in 25 years or so. We also, there were a few storage containers, and we found a few professors' items that aren't even with Ohio State anymore. So we took a long time to purge 20 and 25 years of history, got everything out of the back and relocated. And actually, through this project, we were able to add, I think, about 40 to 50% of total land inside of the car fence. So they allowed us to go into the parking lot behind us. So this is immediately behind the car. At the beginning of the project, they said we could have the grass off to the right, but none of the parking lot. And then we got 1 row of parking. But then over the course of the project, we got to move that line a few times. And so now we have added a significant acreage inside of our fence. So the new fence line is around that entire parking structure. So early on, they, of course, cleared the whole land and emptied that out, put in the construction fence. There is no water retention anywhere around this area. And for those of you that have spent a lot of time at CAR, you know, even after they upgraded storm drains, we still have lakes and floods all over. So one of the first projects was that entire zone behind the building. They had to go underground with the water retention. This was just a small chunk, so they're about 4 foot diameter. Steel tubes there. I think in total we had like 50 or 55 of those come in for a 250,000 gallon storage tank that was built about 20 feet under the ground. And the idea is it's going to serve this whole area as a large capacitance during storm. And then there's a single 24-inch outlet that goes into Columbus's storm system. So we basically have a big capacitance to build up underground. And then it slowly leaks into the storm system at an allowable rate for that area. So, so all that was put in over the first month, and they put in that entire system. At this point, all of the foundations and concrete is built. And just last week, our crane arrived and they started to set steel. They'll be done by the end of October with the steel structure. And they have a goal of getting the building completely enclosed before the cold season. And then on their schedule, they'll build out the entire inside of the building over the cold season and then do all the final concrete and parking lot work into next spring and into early summer. So at the moment, move-in date would be right around our EAB meeting a year from now is when we'll start to be on the building and power on. So we'll see how that progresses here over the next year. Maybe we'll have a meeting here soon in the new facility. So with that construction, underway, we're certainly getting prepared for the new labs, starting to invest in some equipment and get prepared for the big move. Think about new programming that we can do in there. And we're also looking around the property and moving forward on a few other improvements for CAR. So we gave a little bit of a hint earlier in the meeting, but a reminder, we're going to have the event on October 17th. We're really going to talk about the next generation of investments in CAR. The Pontiac Museum, by the way, is a super cool, almost brand new museum where we look at the entire history of automobile in the U.S., starting from the horse and carriage all the way to modern vehicles. And so they've agreed to host us for this event. And we'll talk a little bit about things you heard about today and where CAR's going. But then we'll fully debut the plans to overhaul our student building. If you were at the last meeting, I gave some hints. We talked about some of the challenges that we're having in the back building where we support all the student projects you heard from today. Some updates we need to desperately make, but then some other ways we can expand the programming and really improve the quality of the programming, the number of students that we can host, and safety in the building. So we have spent the last 6 months since we saw you on a really deep dive in that. We actually engaged architectural and engineering firms. One of the early things we had to decide is if we are going to renovate that building, can we even do it? It's a really old structure. It doesn't have a sprinkler system. Where do the code lines fall? Is it something we can renovate? The great news is yes. It actually, by 300 square foot, we fall under the requirement for a lot of very complicated systems we would need to have otherwise. So we were going to move one wall back a little bit, and now I think that we've got a really great modular plan A lot of what we can do is going to depend, of course, on where the fundraising dollars come in, but we have about 5 to 6 steps, depending on investment, of ways that we can drastically improve that building. So the full pitch deck will be at the October 17th event. I just wanted to give you a little bit of a teaser on, from the external shots. We're going to look at a whole new envelope for the building and have fully track control in there for the first time ever. Both for user comfort, but also safety and respectful of some of the types of products that we're working in there now. We're looking at a lot of new spaces inside, thinking about collaborative spaces in a different way, and adding some space for teaching and learning and all the tour groups that come through, summer camps, some different spaces that we can flex throughout the year. A lot more natural light in the building, and then really starting to think about, at least we'll say, starting from the back of the property forward, building this into a campus, not a warehouse out on West Campus, but that kind of place students want to come and spend their day. Lots of outdoor spaces, things like that. So a few different programs ranging wildly in price. We can make some investments in some really cool outdoor space if the fundraising campaign allows for it. But we're starting to look at those things with the architects, and we hope to kick that off here later this month. And over the next year, put some real effort into making this a reality for the next generation of student projects. So look forward to those of you who can make it in October. If you're not in that area or can't make it, let us know. We will be formally moving forward with this over the next year. So excited to talk to you about how yourselves and your companies might be able to get involved and support the program. With that, Giorgio, you're up.
Thank you, David. I'll close with a very few remarks related to our membership program. I'm looking for Jangyan. Okay, we'll be coming back because following this, we're going to have the tour of the new battery cell manufacturing facility. And what I may do is try to get done a little bit earlier so that there's more room for that tour.
Excellent.
So give me 15 minutes and that's probably all I. So a little bit of history. I'll skip the complicated part of the history, although yesterday evening when the executive committee met, we had a fairly good in-depth conversation. But starting in 1999, CAR established, and it really started when Don Hauser was the director of CAR, my predecessor, a consortium membership program. And just to give you an idea of what that has meant for us over the years, you can see here a snapshot of almost all of the companies that have been members over the years. I say almost all because every time I look at this, I can immediately think of one that should be there. It's not, but it's pretty close. And so you recognize the names of companies that were in this room today, and then more. So how has the situation evolved with this? This is a program where members participate by paying an annual membership fee that can be directed, depending on the level of membership fee that is paid, to do a specific project, or it can be pooled among different members to explore other research ideas. And the goal of this program has been to do what we like to think of as pre-competitive research. So in yesterday evening conversation, there were 3 fundamental pillars that served us as being important elements of this partnership we've had with many companies over the years. One, we can do some pre-competitive research to explore some aspects that are of common interest to many members, even though the standards may be competing in the marketplace, but there may be some more basic and fundamental topics there activities. So that's the pre-competitive. The second one is it gives us a small pot of money. Just to give you an idea, this is give or take about right now 5% of the total research expenditures of cost. So it's not a big part, but it's an important part because it allows us to have an ongoing source of funds that we give students. And that brings me to point number 2, which is really this is a talent marketing. And the third one, Mark Schwaber said, hey, this is like being members of a club, right? You can come in when you want a club, ask some questions, we're available to you as, for, small consulting advice, or you are seeking some expertise in a specific domain. Ohio State is a very big thing, and you discover that there's something that has to do with attendance. And I'll send you over to the electrical science lab, right, to find out how you can solve your attendance. So there are these three different elements, are important elements that are part of this program. And we are trying to imagine this is a time of change. Every 10, 15 years, the automotive industry goes through times of change. We've all seen it. If you've been around long enough, that there are ups and downs. And so right now we're in the process of imagining how can we evolve this structure of this membership fee started so that it does things that are helpful to you in accomplishing your mission, and that also provide us with the opportunity to have an ongoing funding source that we can use to recruit talent from typically internal from our undergraduate. We recruit students that will then undertake graduate studies, work on small research projects, collaboration with this industry partner organization. So this is all good. There are lots of good, positive aspects to this. And as I said, it's been ongoing for 25 years. This is year 26. And so it's not a new concept. But there are significant external forces at play today that present some challenges. Generally speaking, the economics of the auto industry, little data point from a short presentation Chris Atkinson gave yesterday. Over the past few years, the auto industry has been short of about 11 million vehicle sales. If you look at the historic 17 million vehicle a year that has been fairly steady for a number of years, there's been a drop in vehicle purchases. The pandemic had something to do with it. Uncertainty in the economic situation today has something to do with it. The bottom line is that if you look at vehicle sales in the US, the GDP addition in the last few years. So the economics for the auto industry, making vehicles affordable and producing what the market wants is one of the challenges. There's also been, there have been a lot of shifts in the technology. Strong for several years, strong effort on electrification. Well, maybe that's slowing down a little bit. What will come next? How will the auto industry be able to face the need for a great diversity of propulsion systems in their vehicles, from the traditional combustion engines to fully electric vehicles? In some ways, the way the market looks to me as a consumer today is that I like to see a wide offering of things that range, the pure electrics to the pure combustion engines. The whole idea of software-defined vehicles and the role of AI in control systems, the growth of ADAS and connectivity functions towards full vehicle automation, with the understanding that that's something that will probably take quite some time to become commonplace. Then there are remote uncertainty related to policy, and this is not just seen strictly within a US context, because the same company that sells automobiles under whatever regulatory policies exist in the US is also trying to sell the same or other vehicles in Europe, in Asia, in South America. And so this policy thing is kind of a global now. And it used to be that in this industry, competition was so fierce that it was difficult to get two auto companies to sit at the same table. What we see today is that collaboration is viewed increasingly as an important component of success in the market. And you see things like joint ventures, we don't mention one, for example, between General Motors and Honda, for example. So the idea is, in this changing landscape, how can we address some of the emerging needs in such a way that we provide you, continue to provide you with the human talent that your companies need to succeed, and address interesting challenges in new technology, software-defined vehicles, electrification in whatever form, all of the connected and automated vehicle subtypes, right, ranging from the evolution of today's ADAS to full automation and the underlying safety and security considerations that go with all this. And we do quite a bit of work in the world of commercial vehicles, not only trucks and delivery vehicles on road, but also off highway, agriculture, construction, mining. So that sector, the commercial vehicle sector, is much more fragmented than the passenger vehicle sector and has a broader range of challenges and use cases. So there are many challenges. So the question we are asking ourselves is, given that we believe, and we hope you believe, that student talent generated by our programs is the most compelling asset we offer, and that we continue to grow and evolve our R&D assets in terms of physical facilities. We heard today about, and you will see soon, of the new battery cell manufacturing lab. But also intellectual. We continue to recruit new faculty and engage them in research related to mobility, transportation, automotive engineering. So how can we help you? And I tend to be pretty direct. There's no point in beating around the bush. The question is, what can we do to convince you, your companies, to make a steady, small investment into this program that we call a mentorship fee program, for us to do pre-competitive research, student training and education, and talent development for your clients. And so many of the companies represented in the room are currently paying an mentorship. What we would like to do is to imagine how we could do this in such a way that it would be easier for you to go up to your next level of management or two and convince them that this is a good thing. So I've said what I wanted to say. Cam, will you come up here for a moment? Because you're going to be engaged with this. Cam Racy is a project manager, an engineer with many years of experience at Harvard before joining Ohio State, who just ended his career as an XR program manager. He's still at par with us. And so we thought of asking him to help us reimagine and reinvent this. So what you will hear from Cam, I just wanted to put a face with the name, okay? What you will hear from Cam is questions from EAB, the form of the survey. You'll think about how to do this right. To provide some answers, help us understand, and specifically one-on-one, because I understand that I'm not going to ask all for the general rule at the same time, what do you think we're going to do? Because it becomes difficult to give an answer to that. But one-on-one, we're going to have a conversation with each of you to try to understand how could we best interact with you in a way that serves your purposes and that you can justify from the business development perspective. And then we'll have to digest that information. And we will send you some questions. Please circulate them around your company. We'd like to have as much of a corporate response as possible. We understand that there are many layers of decision making. Maybe next time we get together, maybe before, we will come back to you with some ideas and thoughts about how we think this might work. Let me also make a clear distinction between the pre-competitive joint collaborative program, small, but very important to us as a student recruitment tool. Let me distinguish that from the fact that we may be doing individual work. We already are doing individual projects with that, probably all of the companies in some fashion or another. So that is a separate story. You're going to see a company XYZ intellectual property related to the Ohio State University, so we can do proprietary research. We get it. We know how to do that, and we're doing that. No, we're talking about here a relatively small level of expenditure to help us maintain an ongoing pipeline of talent coming into this building. So that then, at the day we want to do a big project with one of you, and he says, where do I find a PhD student who could be ready to do this work? Oh, we train one from our membership fee-based consortium project. To think of this as also an early training. That's it. So now, thank you for being willing to do this, and you'll hear from us. And from here, look at what happens next, Jangyan. We're getting ready for the tour. Okay, so let's do a brief intro together, because some of the slides that I moved from your presentation this morning are here.
Oh, yeah.
So if you want to go ahead and explain, these are all your.
Yeah, so we're gonna go through that. If you just go through that 1 minute walk, you can find another gate heading to that reality center. You can find that we are actually literally staying around this area. So we are staying at 109 You can just follow me and just walk 1 minute to the entrance of the battery R&D center. And I think we just talked about the nanotech lab and energy innovation lab is here. The car is at the right-hand side. So you can go follow me. And the base of the battery R&D center is actually 2,000 square feet. And we actually get investment of the $30 million in total to build this facility up and running. And now among them, I explained that 4,000 square feet dedicated to nearly 40-degree Celsius dry room is where we are. You can find that not every equipment is not ready yet. We have the quarter, the line of the equipment for pouch cell, but these are the space we say for cylindrical cell. It's a phase 2. So as soon as we get a funding, we're gonna install this all cylindrical cell line here and start to producing some of the cylindrical cell together. And this light blue space is about the super dry room. We call it super dry room because they have negative 60 degrees Celsius dew point. So the ppm level of the moisture is below 10 ppm. So we're gonna utilize this space for the solid state battery cell processing technology in the future. So we still have we already get the smart quarter here, and we have the glow boxes for cell applications, and we have the calibration machines, but the cathode and anode mixing bay, we still waiting for that delivery of the equipment to fit in and make it operational. So I think around the next time when you visit the car, maybe next spring, you're gonna see the fully operating R&D facility for battery cell facilities. And other parts is where this is a mechanical room, and this is the fire pump. The fire pump is just next to the battery cell aging formation cycle. So we actually fabricate the cell. The capacity of the first application is now 20 cells per hour. I think we are assuming that 20 or 30 milliampere hour. I'm not so sure about the scale, but we are aiming at 20 cells per hour capability, and the scale of the cell can be as small as 2 ampere hour per cell to 100 ampere hour per cell. And the coding line, we have the equipment demonstrated here, the cricket code. So this is our major workhorse that can code up to 10 meters per minute coding speed, and the maximum width might be 1 feet, 30 centimeters long. Then we can capable of that. You can see that one of the special thing about this coding is not looks like a standard coding machine. You can see that every part is kind of modular, which means that you can upgrade any parts in the future. For example, we have a slot-like coding, and also just conventional heating dry. Then the number of the drying station is also you can decide. The number of drying station means how fast you can coding the battery electrode. Now we have the 3 stations, but you can imagine that the current technology I'm investigating is IR drive, so more homogeneous fast coding, so that we can actually swap some of the feature into the upgraded version to improve the R&D processing optimization. Then another cooler that solid-state battery purposes, we have a smart cooler. The smart cooler is principally the same, but actually have a little bit smaller scale, so that we have the identical spec actually. So 1 feet with 10-minute drive speed, cooling speed. Then I think we have the digital pouch cell assembly line. You're gonna see momentarily along the wall, and we have the chip fold stacking unit, hot test unit, tap trimming and welding, pouch cell blistering forming unit, and pouch sealing machine, cell filling and electrolyte filling and degassing machine. And you can see that we can actually have the semi-automated process, because we are not commercializing the cell, but more like using as the R&D scale. So we're gonna go through a semi-automated process from the coding to that forming. Is a kind of one layer of the sequence. You can see we're gonna take a look at around this facility together. Then we are currently discussing about the scale of the cell. So it's a kind of flip form factors, but we still have to accommodate some special standardized cell size because the slitting machine and all this compartment is assembly line is dedicated to that relevant to this dimension. So we are actually under discussions that set amount of the scale. So the smallest one you can think of is 40 by 60, but configuration B, the largest one you can go is 150 by 300. So it's a 15 centimeter by 30 centimeter. That's kind of typical form factor for EV cells. So we have the pouch cell forming and aging machine. I don't believe that it's not alive with OSU yet. We are waiting for them to become here. And we have the digital pouch cell formation equipment so that they can make a formation of the cell. And for single time, they can form and make a formation of the 48 individual cells. And this is another one, cell aging equipment. So we also have the capability car. Car is supporting us to really get equipment inside of gear by the driver. So we can also, each train can host up to 48 cell positions so that max throughput of the system accommodate 288 cells simultaneously. And calendaring a slitting machine is part of the process. You have to calendar the electrode to optimize the thickness and porosity of the electrode. At the same time, slitting is just simply the cutting cutting by mechanically cutting at specific dimension that is dedicated for that cell design. And also we have the warm isostatic press. I mean, it's not typical for lithium-ion battery to having this warm isostatic press, but it's more like a solid-state battery cell because we want to apply megapascal of the pressure at elevated temperature so that you can apply the 600 megapascal pressure. So it's a 6,000 bar, and we max temperature is 145. The goal is, because this is not liquid but solid, so if you want to densify the solid electrolyte, you have to mechanically pressing it. And unique press is maybe good for lab scale, but if you want to bad specifications, isostatic press is with the temperature is the way to go. So I know that it's kind of luxury, and now knowing that many of the industry partners trying to make the cell purchase them without having that isostatic press because it's kind of expensive equipment and slow. But I can say that this isostatic press has been used for food industry for many years. So, for example, you have they actually use isostatic press as a part of the food manufacturing processes. And now I see that the printers actually is a 20-minute driving distance from north of the Columbus. Yeah, they actually fully grab the isostatic press. They are actually developing inline and not batch to batch, but they have the inline continuous line for isostatic press. Very impressive. They have the soft rubber band, like if you go to Walmart and you have the moving cart, the rubber belt moving the food, isn't it? They check the same thing. They actually rubber belt and your pallet on top of that. The other rubber coming down and pressing it as a part of the ride. So it's very similar concept of the calendaring machine. I have no incentive from this company. I'm just saying what's going on in the outside the world about this technique. So very excited to see that we're gonna actually equip this one at part of the item. So I believe that this equipment is now on the manufacturing and delivered from the north side of the Columbus, and we'll be sitting around this left space, here. So this is actually anode mixing bay. So we have the anode coating machine independently. In the future, another anode coating machine will come here. This is the anode mixing bay, and the quintos, the high isosceles test will be installed here, so that we can actually be used as a part of the process. So besides of that, we have a small mixer. So it might be best to just we walk together down and just explain more detail with the real example. Thank you for your attention.
Yeah.
Well, thank you again, for joining us today, and please, enjoy the tour.